I may have dumped a little bit too much cream into the coffee, but I have to because like it's gonna expire on the 9th. Mm. How about that damn algorithm? Ugh. Good. Mm. Hmm. Okay, so two planes makes a point. So the trouble is you don't know if the plane set um, forms a proper um, face of the solid. Let's imagine a bowl with like five sides. It's got like six polygons in it. It's got the bottom. It's got one, two, three, four, five. So the goal is to start with the bottom face and track around the sides. But the problem is what if the planes that I choose are bad? Like, what if. It'd be nice to have like a 3D model and I could like mark it. Uh, I can probably draw it. Okay. Big lag. Okay, so let's say we're looking down at the bowl from the top. So the bowl has like a pentagon. Ooh, got him. And yep, it's a pentagon bowl. We're looking down at the bowl from the top. This is the bottom of the bowl, and these are the sides of the bowl. Okay, so what if you pick this face and this face as your first two faces? What if you're like trying to find the edges of this face, and you just the faces are in random order, and you're just picking some to start with. You really need to find the corners, but you got to start somewhere. So the problem is, um, when you find the intersection of these, it'll be like back behind this face. That's a dotted line. There'll be an intersection here behind. That's just totally irrelevant to the convex solid. So the first face you choose could be occluded by all faces. It could just be like outside the solid. The second face you choose, same thing really. The pair of faces could form an edge that's totally irrelevant to the Goobert, to the convex solid. But to form a point, we need three faces. So like that one, now that would like single out this vertex, but that's also behind. But like you can only start to know if it's behind after you select 3, right? Because like this line crosses through the planes. It's like no guarantees it'll be aligned with anything. So the line is infinite, the faces are infinite. You need 3 to start making any headway. Rio. Okay. But then what you can do is detect that the point is behind one of the faces. So like let's say this is our face, this is our face 1, 1. This is our face 2 and this is our face 3. So now we have a point. Oh, we have a point. And we have to determine if that point is in the convex solid. So we check all the rest. Check, check, check. And we go like, oh, it's actually behind this face of the bowl. It's a bowl. Face number 2 is the bottom of the bowl. And we're looking at it from the top. It has 5 polygons. It's a pentagonal bowl. It's a very low poly bowl. So the question to me is which so like clearly we don't have a set of 3 faces that form a vertex that is on the convex solid. So I have witnessed that this face occludes the vertex. Okay. Which face do I replace it with? Does it matter? Can I choose either? In this case, yes. I don't know. Okay. Yeah. So there is some sort of strategy. Think about this. If we've detected that this face is occluding the vertex, and then what if we choose to replace it with face 2? Because like it's just a bunch of faces. Like we don't have any orientation here. We don't have any preference. So what if we replace it with face 2? Well, now I want to keep that. So now our 3 faces are this one, and this one. Those 3. Because we replaced this one. So now we're on, we like are on some sort of next step of the algorithm. Oh, that's not what I wanted. So what the hell, man? Do the green. Did I have another? Goob. Hello? Oh my god, bro. Okay. Why did it do that? That was irritating. Alright, so now we have to follow the planes. And so this plane, this plane, this plane intersect on this line and this line. And if we follow those lines, they form a point that's under the bottom of the bowl. It's like somewhere down below. And we're in the exact same scenario now, where we have a point that's occluding. And how is that any different? How do we like know things? Do we like pick the closer dot product or something? How do you know anything? How do you make forwards progress and like figure out some pair of some triplet of three faces that form a vertex? I guess you could brute force it. Yeah. Yeah. Mm. 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 That is so creamy. Just put whipped cream on top of the coffee. I may actually do that. That sounds fun. And like I have to use whipped cream. I guess it's good until June, but that sounds fun. All right. Surely this makes sense. Go here. Wait. This is so dumb. Oh. We lost some air. What am I doing? Just put a little bit of whipped cream on it. It'll taste great. And the frightening part is that I will. There is chocolate milk, cream, coffee, sugar, and whipped cream in this. Hear that sound? Chocolate milk. That's right. I put chocolate milk in my coffee. Did you see the diagram? I'm trying to like concoct an algorithm here. Why don't I get a prop? I did. Nice. That's frighteningly tasty. I can't be a whipped cream devourer. I can't be. All right, I got here a bowl. So, like, what I'm imagining is that what we're seeing on the screen is like a low poly bowl with like 5 faces around it, and then like, of course, the one in the middle. And what we're trying to do is find 3 faces that form a vertex, that intersect at a vertex that's on the convex solid and is not occluded by any other face. But what I've shown here is that if you select these 3 faces, 1, 2, 3, then that forms the red vertex here. But that's occluded by this face. So what if we replace one of the faces in our list with the occluder face, this one? Well, so if our faces, so if we replace this face with the occluder face, just like picking at random, then we have this face, this face, this face, and then that forms a new vertex that's underneath the bowl. It's underneath the center. And we're in the same problem. Now the face we just replaced does that actually help? Okay, if you do some permutations on the new face and the old faces, you could find out which combinations don't occlude. Is that guaranteed to have a better combination? I feel like it is. There's got to be some sort of quicker check, though. Like you can just do a couple dot products and it's like an equivalent choice. Oh my goodness. The whipped cream is unwhipping. Uncreaming. Is it just going into the coffee and becoming more cream coffee? Bruh. Ugh. Oh, well. Maybe I can start here. So we got some planes. There are planes. There are planes. Um, um, I'm sure there's a better way. Okay, yeah, no. It's actually only 4 checks. So, because it's like 4 choose 3 ish. It's well, 3 checks, I guess. Okay, so ding 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 ding. We got a list. Ugh. Okay. So really, we have a while loop here. So, um, buh. Oh. Okay, actually, interesting. We're saying plane 0 is fixed. So we're only going to replace these ones. Is that bad? Are we allowed to do that? I feel like that's allowed. I feel like that'll work out. Who knows? All I have are feelings. No proof. Oh my god. So what I gotta do is this is a reference. So these are all references to objects in this like master list. So I can check pointers. I can compare the pointers to see if they're the same object. Oh my goodness. Okay. So now test if any other faces occlude the, what did I call it? Intersection. Oh god, I gotta actually do the intersection. Oh my god, the whipped cream is gone. I did not know that about whipped cream. Okay, this is... Determinant, blah, blah, blah. I think it's solve 3. N dot P. So this is just... sick. So I can actually use this math. Okay. Oh my god. Do we care if it's a reference? Plain handle. Can you coerce handle in the reference? What? Can you like steal the reference? Can you go like, oh, reference plain 0 dot as ref, and then that's a scoobity doobity. Yes. Okay. Cool. Okay. So I'm gonna do reference to plane. I think converting the memory to glams is not a big deal. Plane. All right, so this is our little algorithm. Wow, what a great epsilon. So what's the epsilon? Okay, what is this? 1, it's 2 to the negative 10. Okay. Surely. Okay. Okay, so yeah. I think I'm just gonna do this. Vector. Think I can from array sref or something like that. What's the okay normal? Oh yeah, so these are not real. Oh, what the hell? Okay, it's not ambiguous, but you know what I mean. Not const. Okay, well, what's the easiest way to make a power of 2 in floating point? Bruh. I don't know. There's no like, okay, what about, is there like, there's nothing. Okay, I give up. What number is it? 2 to the power of 10 is 1024. Wow. Okay. Is it 10? That would be crazy. Because it's like 256 times 2 times 2. It is. Okay, so we can do. Should we do them all at once? Nah, we'll do it one at a time. C0 dot normal dot frick. What is it? Hitter. Array. Alright, what does this give you? Add submul, nice. From okay, so you can into. Okay. So I can go like glam vec3 from array the boom into. And surely they say yeah, surely they say like no, unlucky. It's not inline. Oh. Okay, but like this is just the converter. It's okay if it's slow. It's okay if it's slow. Only has to run once per map. Relax. 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 Okay, so N0 N1 bop, and then N2. Oh, I missed one. Yeah. And then our little D guys down here are... yeah, I'll just do it. What is it called? Dist. And that's it. Wow. 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 Alright, so this is stolen from my proprietary code, and it's put into an open source module. No way. I haven't published it yet, though. But I intend to. Okay. Solve. Wow. Wow. Debt. Okay, so this is like unitized normals, right? Surely. Who knows? Okay. Solve 3. Wow. So it doesn't matter. 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 Just make it work. Then you can think about optimizations. Okay, we got 4 brush, 4 side, 4 loop. Wow. Okay. I don't even know if the planes are gonna work. I'm doing all this off of your word. Did you really not have to write anything like this? Okay. Okay, so we got the big solve. Amazing solve. Solve. I barely understand how the code to begin with. You're hiding all this from me, aren't you? I just know it. You're keeping it all to yourself. Solve 3. Okay, so we got bop, bop, bop. All right, so I just gotta call this function like 3 trillion times. It's not. It's bad, but that's okay. It returns an optional value. Top bottom face is disappearing. Is that because of degeneracy? Is that like collinear vectors? Collinear vectors in floating point is like trolling. That there's floating point is trolling, honestly. If you're using the floating point, you're throwing. Bruh. I could like pre-convert the list. I'm just gonna not worry about it. I may be throwing. Floating point? It's so standard. It's so ingrained. Everything is floating point. Nan. Bro. I think I need brute force. So like once I get a thingus, then we're chilling. But when you're starting out, finding the first edge. Yeah, some of my outfits were Nan spam. That's loading point. Some of the Roblox models, the meshes, just have Nans. They're just Nan. And it's like, okay. They're just, Nans are saved to disk. Bruh. Okay, the problem I'm seeing is, imagine the convex Scoobert Doobert, the convex solid, the convex shape with 171 normals. My guess is that it's just like a box or something ridiculously simple like that, but there's like 160 top faces. Oh, that sucks. Oh, that sucks. Why are they there? Yeah. That's my okay. What if I just print it? I have the code. Let's go take a look. See. Yow, yow, boom, yow, and it's up. Open source. Wait, this is based on Trey's code. Leaked. It's just a little bit of linear algebra. It's not the biggest deal. Okay. Let's go over here. Bop this. Bop. And then now we have this thing. Oh, I didn't freaking save. You goobert. Save. Overwrite. You goobert. Okay. Check out. Okay, so we got the code. We got the code. Min by key. Giving brush. So now we have brush. We know sides. Count. Print it. We want to print it. Print. Yeah. Ooh. I'm just gonna like. It doesn't matter. It doesn't matter. For loop. Side in. Bruh. Side. Bruh. Side. Plus bruh. Num sides. Open. Loop. Yes, good, do it. Yes, good, do it. Yes. BSP plain. All right, we're gonna. What is it? Oh, it's. This has never errored before, so we're just gonna zoink it, and then this unwrap, yoink, zoink, side dot plain. It's so indirect. There's 4 levels of indirection just like to get to the planes. Okay, plane. Okay. So there's a plane. We gotta print it. Print the plane. Okay, print plane. No way. Disgusting. All right, what do you got? Argument is never used. That's so true. You are so right about that. It's so true. All right, what do you got? Cannot move. You're so correct. That is, I was a fool. Okay. So I'm printing the normals. We're just gonna print the D's as well. D's planes, dist. Yep. So we want to do like dot 3, I think, and then I don't know. We'll just do it about this. Okay, so let's see. Let's see. So we go to and then we go cargo build release features source. Okay, and then new tab, lower tools, boom, run, find the map, X. So Enokia had 171. All right, so go. Oh, I was doing the wrong one. Well, that looks like a cube, doesn't it? So we want max, the maximum delicacy. Hashtag not my file format. All right. Wow. There's many. Okay. Okay. All right. Let's see what happens if we dedup. Collections. New. Actually, we can use set, can't we? Set. Okay, so. Okay, so I'm just gonna go like dedup dot put insert that one, and then I'm gonna do an array of 4 values, and the values are gonna be plain.normal.x.2 bits to bits, bro, and then all the other ones. Bum. So dist and y z. And then, oh, here we go. Print dedup len equals dedup.len. So how many duplicates are there? If we just smash the bits into a hash map. I ain't looking through that myself. Make the computer do it, okay? Just hash it. Just hash it. Oh, okay, there's quite a few duplicates. All right, yes. Okay. So clearly we need some kind of what the hell? What is this? Oh. Like, this is just gonna be a ball. There's 121 unique planes. Why is there duplicates? Why is there 120? Oh my god. Very wacky, very wacky. Um, all right, so this is like wacky brush. Print the wacky brush. Cool. Okay, so we know it's wacky. How can we avoid O of n cubed computational complexity during the design of this algorithm? So I've selected 3 planes here. Plane 0, plane 1, plane 2. Let's just assume that all 3 of them are duplicates. How do you fix that? Oh, I've got an idea. So, what if I select by opposing normal? Or something. What if I select by like most perpendicular normal? So like the dot product that's the closest to 0. So that way it's not like finding opposite planes. It's finding... I think I have a winner here. So I think this is a winner. So this is O of n. Okay, well the per face is like O of n. Because I just would select the most perpendicular, and then do the edge finding, and then do the edge crawling. Yeah, I think I just loop over all planes a bunch of times. I couldn't tell you what the final complexity is, but I can tell you that it's better than brute force. What are you making? Stream title, planes to faces. So in Source Engine, you have brushes. Wow, it's a brush. What the hell is that? So a brush is a list of sides. Okay. So then the sides, each side knows a plane. Okay. So we end up with a plane list. Okay. The planes are like infinite planes. They have no end, but they like form a solid. And it's a convex solid. It's always a convex solid. That's weird. I want a mesh. So I am taking the planes and finding where they intersect and like making vertices and like this is a face, and I'm turning the planes into a mesh. I'm designing an algorithm to do that. So, okay. Pick any. Pick the most perpendicular planes to begin set of Shri planes. Okay, Shri. So now meow, 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 meow. I don't need the IDs anymore because I'm not selecting it that way. I don't select that way. Okay, so what we do is we go plan list dot iter. Oh my god, iter. Yes, dot Is that a plane? Oh. Why is it a... Okay, it doesn't matter. Okay, so we got a plane thingy. Isn't that just great? So now what we do is the dot product. The dot product. It's the dot product. Find least abs. Oh, okay, but it's okay. You're gonna find it. You're gonna find it. There's the list is not length 0. We checked up here. I don't know if the compiler can get rid of that, but it does not matter. Unwrap. Okay, so okay, so we're gonna do normal 0 equals plane 0. Oh, numerate. So true. So true. Okay, so I'm gonna do like this because I think that's nice. Plane 0 dot normal dot into semicolon, and then it has no idea. Okay. Glam vec3 from array plane 0. There we go. Okay. So now we have a vector 3 normal. I should probably have like a function to do this, huh? Because like I'm gonna do it a lot. G. Yeah, it's literally this. Boom. Okay. Inline. Okay. G. G. Oh my god. Okay, so G. Amazing. It's G. Insane. Okay. So we got a normal. It's a normal. That's a normal. Give me that abs. What? Why is it? Why did this go away? Okay, so we go like let n1 equals p dot normal g. Then we do n0 dot n1 dot abs. You need that abs. So then that no semicolon. This is you take. Is that allowed on floats? Plainless to hanger. Why does Rust have to be so correct? I'm gonna heat up my coffee. Rust is like, actually, floating points have this issue where they're not actually ordinal because the NaN values are they're not ordered properly. Yeah. Okay. Yeah. So you can write your own float comparison and use that instead, right? Oh, I've done better. I'm just going to pre-convert it. All right. Let face list. I think I'm going to do that. Equals to plain list into iter dot map. Plain. And we got plain. Then we go like. Oh, I don't have the physics. I wanted to do one of these. Expensive for a less than comparison of floats. Well, I'm going to bake the list, so it doesn't really matter. And also, this only has to work. Even if it takes an hour per map, I only have to do it once per map, and then I have the map converted. So it's not that big of a deal if it's slow. So yeah, I have my own fixed point numbers. I made a library to do math in a new way. So I'm going to convert it to that so I don't have to worry about floating point pain. Okay. I don't remember how to do this. Oh, there should be examples like right here. Like literally like right next door. Open your goddamn eyes. Oh, is it valve transform? Good God. So try from F32 array. Surely. Should I do the valve transform? Unwrap. That's gonna go well. Alright, I'm just gonna use the valve transform and we're gonna call it a day. And then it's gonna have a nan, and then I'm gonna cry. Don't nan. Okay, so we're gonna do face. Normal. Boom. P dot normal. Do it. Normal. Into. Surely. Does it take a float? Yeah. Yeah! And then we do off. What did I call it? Dot. Beautiful. I like that better. Collect. Yeah. Oh. Okay. Okay. You have your numbers and I have my numbers. Let's go our separate ways. Dist. 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 D. G. D. G. G. Oh my god. Alright. D. Do it. Do it. Do it. Do it. Do it. D. D. Try into. Surely this works. Okay. So that's great. This is how you write code. Okay. Dist. Do it. Into. Do it. Do it. Do it. All right. So now this is something that exists. Yay. It's a vec of something. Very big Rust. Okay. So we got a face list. We don't do plain lists anymore. We got faces. Now we got faces. I don't know what you're talking about, planes. We only have faces, you know. I've never seen faces in my life. Okay, so we got the dot product, and then we got the Ooh. So the G, you don't need the G. We just have the normal. Wow. Ah, yes, the G. Okay, so we don't need these silly pre-transformations anymore because it's pre-transformed. Pre-transformed. Yeah. Yeah. So the silly thing about this is that the precision changes after the operation here. It becomes twice as precise. So it's comparing a number that's twice as precise as either of these. But that's what the result of the multiplication is. If you multiply two very small numbers, they become very, very small numbers. If you multiply two very large numbers, they become very, very large numbers. So the range of numbers that can result from the operation is larger than the input range. And that's what my little library takes into account. It expands the precision to account for the entire multiplication range. And you can make perfect calculations. I love making perfect calculations. Wait, what about... Well, how do you know... I guess it doesn't really matter. So this one, great. We found the minimum dot product. We found the most perpendicular face. Oh, the cross product. Of course, it's just the cross product. Awesome. Okay. Cool. Okay. Great. So now, crossy. It's the crossy cross. Okay, so face 0 dot normal cross face 1 dot normal. So we got the crossy cross product, and that is also a more precise number. So now we want to find the face with the largest dot product to the cross product of the other faces. So it's the most perpendicular to both previous faces. Yes. Okay. So basically we're now the same thing. Whoop. And then, but instead of do like this, you do max by key. So this is find the most perpendicular face to face 0. And then this is find the most perpendicular face to both face 0 and face 1. No way. So hit crossy norm. Oops. Normal dot abs max by key. Surely. Oh, there is no normal. I am the normal. Okay, so this is now a triply big number because this is a doubly big number. So this is a even more expensive calculation, but it's not that bad. It gets really bad if you keep going. Oh my god. Okay. All right, so this is the way I imagined doing it after I wrote it, but floating point numbers came and slapped me in the face. So I'm just going to do it this way from the beginning. Okay, so we got the face. So we can drop plane here. We're not going to, nobody, who even uses that? So we don't need the G function. It's a face. This is not a float. Okay. So we can actually steal this directly. Again, steal. But I don't know if we need that. So this is like, you know, technically a vector 3, but like it's kind of overboard, you know. So if I say this is face, it should just work. Oh goodness gravy. Why don't we stuff this in a new module? This is getting out of hand. So let's say this is math. The most precise port to exist. Yeah. I guarantee you we're gonna hit a nan. I'm calling it now. We're gonna hit a nan. If there's gonna be a nan, it's gonna explode the entire thing. Okay, what do we call this? It's a algebra math planes to faces. Brush. Good enough. So bump. So let's say should I put the whole thing? So no. Mesh builder. That would be nice, wouldn't it? So I want to like so it's like brush to mesh. This is like mesh to mesh. It's model to mesh. Buh. I think I start here. So I go like bruh. Function decompiling by various programs. What, like generation loss? Encoding a JPEG as a JPEG, cropping it. Brush to mesh. So we got BSP is a bruh. I said it. And then the output is a model mesh. Actually, we got our own little module here, so let's just like chuck everything. Okay, so mod, what do I call it? Bruh. Okay. Bruh. Okay, so we got we got functions. I got functions. I don't know about you, but I got functions. Bruh. 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 So, I need another, like, 2 of these. Okay. Oh, okay. So I'm returning an error? I think that would make sense, wouldn't it? So I think I'm gonna, so this is like function planes to faces. I'm gonna like take out this goob and do it in a less goobing way, so that it's kind of, you know, less tabs, right? Just less indentation. Okay, so we do this thing in here, and then we do I mean, that basically is the conversion, but like, yeah, it's 1. So like, just like that, right? Okay. If let sum, I think I can actually drop that because, wow, I gotta sneeze. Okay, so I could say option, but I could also say error, and then I could specify why. So result mesh brush to mesh error. Wow. Now we're getting technical. Technically an error because one of the values had a NaN value. Okay. The bruh. Shh, brush. Bail. Yeah, no. We can do way better than that. So so look at this. We can go like goodbye tabs, goodbye, and then get dot or ear question mark semicolon for sure, and then ear. How do I rate this good? Okay, we got an error. If there's an error, it's an error. I have an error. All right, there's no this error, so we're just gonna YOLO. Okay. Oh. So this is slice, brush sides, and range, range is range. I believe it's like std range. Oh, it is not. Wow, what? It's that one. Ooh. It's not ops. Ops is a trait. That's how I knew. It's because it failed before. It failed me. Okay, so let sides range equals to get okay or error range. Boom, boom, boom. Got him, coach. U size. Range doesn't have utilities. Okay, U size. It doesn't matter. It doesn't matter. I don't care. Nobody cares. Okay. So now I need to like convert that. I want to like collect without specifying the generics, but I don't think I can. So I'm just going to specify the generics and we'll call it a day. Colon, turbofish. And then okay or brush to mesh error. And the error is missing plane. Wow. Missing plane. Plane is a I-16. We don't actually know which side it was. And I don't think we actually care. So I'll just add it. I'll just add the like. So these were never problems actually. So I'll just add it if it becomes a problem. Missing plane, question mark, semicolon. Okay, so now we have plain list. It's a plain list, very plain. Tabs are goated. Okay, sussy planes. So this is tetrahedron requirement. Face count. It's how do I say this concisely? There's not enough faces. You need at least 4 faces to create a convex solid. Tabs for us is crazy. Do you mean I should use spaces? Or are you saying Rust gets a lot of tabs? I'll say invalid face count. Invalid. So who did this? U size. Count. Yeah. Return error. Count. Plain list dot length. Wow. Semicolon. Oh, must follow the language's style. But think of all the bytes you're wasting. You waste 3 bytes per indent. Just like, look at how many bytes I'm saving by not typing spaces. It's actually 10% smaller file size. Think about it. I'm sorry. Okay, so these have unwraps. I could instead have a fallible transform. I'm gonna write that. Okay, bing bong. Okay, so then the last step is generate the mesh. Great job. Why? Oh. It's okay. It's death. We have death. Why? Why? Lib. Blip, blip, blip. Okay, we're missing, yes. Build, yes. Give me that. Okay, so we're gonna do if let sum equals crate brush to mesh. Wow. Then push mesh. Insane coding skill. Okay, wow. And then up here it's say nothing. Okay, over here it's say boom. Got him. Let's go. Okay. Model. I'm just gonna import that. Okay. Oh, it actually got the thing. Okay. Code actions, do it. Okay. Code actions, do it. Code actions, do it. Code actions. Yeah. Okay. Ooh, got him. Okay, do it. Do it. Code actions. Do it. Code actions. Do it. D0, D1, D2. Why don't I just slap them in? We can do some new lines to make it look at least semi-decent. Not loving it. All right, it's fine. So this is like this. And then up here, we don't use this. Good. Good. We can also use this. Okay, so expected 4, found 3. Well, that's okay. We can just do 3, 3, right? Cool. Okay, what do you want? And consider the following. Okay. Can I do that? No? Okay. Uh-oh. Surely. Okay. It's only used once. I'm just gonna hard code it. So this returns a mesh, but what we do want is the mesh builder. Oh, actually it's in model, so it's fine. Okay. Okay, now we have a little module for converting the brushes. Okay, so now we have the face list. Oh my god. Wait. I'm excited because I can remove generics. Faces. Psych. It doesn't matter. Okay. Wow. 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 Okay. So plain list. So I am doing an iterator here. Why iterate, allocate? Just do it directly. Like, oh, okay. So can it see through the fog if I do this? So if I go like, rah, rah, and then I go, the remove the fog, I think this kills it. Because like it'll, if I, okay, let me just, and then we do, so this is question mark, semicolon, let plain equals. And then we do face like this. And then we can do some face. P is plain. And then this goes away. And then this is immediately faceless. The faceless. Not quite. Ah, okay, what? So we get some, none. Iter map. This is so sad. Okay, so we know this is a vec face. Unless we go like this, then it's like, huh? What is that? I don't know what that is. Oh, this is plain list. What? I don't know what that, unknown. Okay, so if this is so sad, but Steve Jobs died. This is option vec of something. Possibly even something, okay. Unlucky, but we don't do the big bad anymore. It's cool. Okay. Wow. Great. Okay. So now I said mutt because, okay, so this is just finding faces that aren't going to be problematic. So problematic faces would be like degenerate. They would possibly like even be all facing the same direction. So I just have to like scan intelligently to begin the algorithm. Does this fail? No. So I think what if I do this mutt intersection and then like, can I just unwrap that? Cause it's like if this fails, you're cringe, like get out of here. So this planes of faces, like I guess I can just option question mark it. Option faces, I don't know, man. Vec, no, it's sure. We'll just make a little struct thing. So face, struct, faces, vertices is vec. Yeah, vertex. Integer, vec. Yeah, it's that one. And then faces is vec. Vec. Vertex ID. Or do I just go like straight up, just blast it out? I think I'd literally just blast it out and just, we don't care. And then we can, like the mesh builder can deal with it. Just like let the mesh builder deal with it. I could also patch the mesh builder in as a mutable reference to this. That would work. Could call the like face deduplicate, the vertex, acquire vertex ID thingy, acquire pause, whatever. So we have option faces. So this is an option. If this fails, you're done. If this fails, you're done. If this fails, you're done. It's just like invalid. Okay, so we have intersection. No way. So what do we want to do is loop through the faces again, like this. We go like, oh, ooh, new face, new face, new face. The face of Bo. So this is a face. It's some kind of face. And it's not one of the faces we know. It's a new face. Buh, 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 buh. I'll just write it out. Core, PTR, address is equal. So if face 0 is exactly new face, then it's not a new face, is it? Then continue. And same. Why did it do that? Face 1, face 2. So this is what I was talking about, like comparing the pointers. So I could use indices, but like, why use indices when you use pointers? And it's like, cool. Whoa. Isn't that great? So now we know known new face. So if you solve the face, but it need not actually be solvable. It could be degenerate, and in that case, we don't care. Just like throw it away. So this is new intersection. Oh! So we go like, if so yeah, it's a new face. Okay. Occludes intersection point. So the thing I wrote comes next. Okay. If it's intersection. Oh, good God. Oh, good God. Oh, good God. Okay. New face dot normal dot intersection. So we actually don't need the divisor here. So we can actually just grab the numerator off of it. Because like we're just testing if it's greater than or equal to 0. Is positive. So what does that mean? So we got the, if the, I need to test against the, okay, if the dot product is less, if the intersection point is dot product new face normal greater than new face greater than new face dot dot like that, but we have to fix for this, I believe. Then, actually, do we need to? Oh, we do need the frick. Can you even dot a ratio? I don't think you can even do that. Oh, good God. Why would you do that? Okay, shut up. I don't think you can do this. So we can just like manually do it. Num. So apparently we do need to multiply by the den. I'm just going to do it manually. Intersection den. So that is the determinant. So the new face dot multiplied by the determinant is less than the normal dot the thing. So this is like, look at how this magically works out. This is like, each of these multiplication is a widening operation. And I've represented this as a ratio, but it magically works out to the same width because it makes sense as a calculation. So this is an exact, like literally exact. It will exactly know if this intersection point is behind the face to like ungodly precision, to literally infinite precision actually, because it's exact. Like the representation isn't infinite, but it's exactly correct. Okay, so occludes intersection point. Obviously it's unnecessary, but like look at how easy it is in my libraries. Yo, my libraries. Woo, woo. Okay, so what does this mean? So if the new face that we're testing occludes the intersection point of our previous 3 choices of faces, it means that our previous 3 choices of faces, the intersection point does not actually lie on the convex solid formed by the planes. So what we need to do is replace one of the faces with the new face. And that's where this comes in. What does that mean? So like, okay, if there's a new intersection, that means okay, what I have to do is I have to test that the jettisoned face doesn't occlude the new intersection. The jettisoned face doesn't intersect the whatever I just said. Okay, so new face, my face. So face 0 does not occlude the new intersection. I don't know. Okay, so this is like break something. I don't know. What the? Okay, so this is just the exact same. So we've got new intersection here instead, and then this is face 0 instead of new face. So if it does occlude it, then don't do it. What if it is actual equals to? It needs to be better, doesn't it? Not less. So like if it's exactly the same, then it's then it doesn't matter. It would be an equivalent choice-ish. So we don't really want to like jump around if it's an equivalent choice. So Let's, I don't know. Yeah, I don't know. What am I doing? So I think this is break. This is the break condition. So this is for the loop. If we find a new face, so we do go like face 0 equals new face, right? What do you want? Oh, we can't replace face 0. Silly me. Don't try to replace face 0 because we are trying to exploring that face in particular. Okay, so instead of face 0, face 0, we go like face 0, we replace face 1, and then face 1. So notice how it prevented me from doing that because it wasn't mutable. Thank you, Rust. I would have just written that. All right, and then my face 1, face 2, face 2. Okay, so new face includes intersection point. If that's true, we have to change the intersection. I did say mutt. I'm a genius. New intersection. Mutt. So we do the calculation once and we reuse it. Okay. Okay, so I think that's it. How do you know? Oh, it's here. It's here. Wait. The big break, right? The big break. How do you say this? I forget how to do this. Rust break outer loop. Colon. Oh, I almost had it. Okay. This is the find. So this means break find, right? Because we did it. If, oh, that's after the, yeah, wait. Continue. I can do it like that. No, can I do continue outer? Because that's what it needs to do. Is it needs to go whoop to here. Okay. So if we don't replace any faces, then you're done. Oh, actually, we don't need this because this is already down. We could label it anyways. So this means we have found a set of faces which for which the intersection is on the convex solid. For which the intersection. So that's cool. Cool. So now we have set up part 1 of the algorithm. Now we have to do part 2. Okay, so cool. So now part 2. Let's do follow edges around face. This algorithm is not looking too shabby. I hope you're appreciating how cool my library is. How it's not. I'm not having to like change the bit width of the numbers because it just so happens to work out, because it just so happens that I'm doing calculations that make sense. This library is epic. It's open source too. You can just use it. It'd be even more epic with const generics, and it's like slow, but it's perfect, right? It's exact. It gives me the warm fuzzies. Or I guess intersect. Precision overspeed for my BSP bakery. Yeah, you can just use it. It's not on crates, but I mean, it's not that hard to set up. Like, all you need is this thing. You just go like, boom, and then you have the StraferNet library, and then I'm using it from Common, and that's a bit weird. But yeah, so then you just go fix wide. So I'm using it with deferred division, zeros, so that's like solving polynomials, and wide multiplication, which is the widening. I have like features, so like you can sort of disable the weirdness and just use it as a fixed point library. And then this is my vectors linear ops, the least obvious name for a vector library. And I need a library for it because nothing else lets you change the type with a like multiplication operation. And then I have the same Gooby stuff. And then named fields is a feature where it derefs into a struct. So it's an array, but you can access the X component because it derefs into a struct. It's really cool, actually. It's unsafe, unsafe, but like we can go look at it. Actually, it's kind of cool. I was happy when I figured this out, but then I found out that which library is it? Nalgebra actually does this as well. I was like, I thought I invented it. So you got matrix array. Wow. And then named. So these are the named variants where they have X and Y and stuff. And then, oh my God, we have a macro. So we deref unsafe transmute. That's it. So it derefs into the guy. The target equals guy. So vector 2 is when it is length 2. And it needs something like that to like make sure that it's like sound and stuff. Or so I saw. I don't really know for sure. And then the vector also needs it needs repr transparent. I am not seeing that here. Soundness. Why? Why didn't I have that? Freaking macros. So like this is so if this is where Const would like remove this like annoyance. Oh, this is matrix extend. So you can like have a matrix and then you extend it by a row or extend it by a column. It's cool. Cool stuff. But like other libraries have that as well. I just needed to make a library, right? So why is this not compile? Why not? Why? Who did this? Okay, it's should we print? Probably. Okay, let mesh result equals to this mesh result. Hello. Oh, B mesh. And then okay, mesh means put this, but then error mesh means print this. Brush mesh error E. Need semicolon. Help. Okay. So then I have to go over here and I go like, so I have to go like, give me an error, give me an error, give me an error. Do I have an error in here? Where'd the semicolon go, you goob? Error. I need an error. Help. Is this guy? This guy. I know this guy has an error. Give me that. Isn't there better? All right, whatever. That's good enough. Okay. Zoink, and then impl. Ah! Okay, wow. Okay, there we go. We got it. Oh my god. Okay. Derive, debug. Got him. Okay, the error goes away on that one. Cool. What's the holdup on Const generics? The holdup is that it's outrageously difficult. So the folk Boxy Uwu is the head of development for Const generics on Rust, and Project Const generics 3 years ago, but like doesn't need to be kept up to date on this particularly. They're working on it, so like I saw some updates. Like if we look in this Rust, like const stuff, you know, this feature, generic arg, you know, they're like working on it. So the main issue is that it's outrageously difficult, and like C++ just sort of glazes over that, and like you have it like puts the buggy software onto the consumer of the software, so you just have to like work around all the unsoundness yourself. Whereas with Rust, the idea is that it works and there's no bugs. So yeah. Oh my God. Okay. Repeatedly update face 1 until all faces form part of the convex solid. So this is actually assuming that face 0 is part of the convex solid. Is it not? Not if you have 171 faces and there's 60 duplicates. Okay, think about this. What if you have, so if this is the normal vector, what if you have a face like this, and then you have a face like this? It literally just occludes the entire other face, and this face is literally never part of the convex solid. It's possible. As if the faces exactly are the same normal. You can. It doesn't actually have to be exactly the same normal. You can just have. Okay, so if you imagine 6 faces that form a convex solid here, and then like, so one of the faces is like this. What if you just have a face like that's just over here, and it's just like, oh yeah, everything is on that side of me. Well, yeah, we know that. There's already 6 faces forming the stuff over here. We already know everything is over there. There's just a degenerate face that is completely not part of the solid. So I need to like... I think I can do that by testing the final Scoobert Doobert right here. So we have intersection. We can just go like, if intersection is on the solid, basically. Excuse me. Are you allowed to do this, or is it gonna be like, actually, this doesn't implement eq? I don't know. I don't understand metadata and fat pointer. If the same as eq, ignoring any metadata, like, I just like it. We only care about the pointers. Mm-hmm. Din. Oh. Interesting. I see. Okay, so this knows that it's an I-32, but the pointer is the same as the pointer to the entire array. So this guy goes like, oh yeah. Whereas this guy, the types have to be the same. Okay. So it's really the difference is in the generics. The difference is not, it's not like doing extra checks. Detect ambiguous wide pointer comparisons. Huh? So it's, yeah, okay. T. So this is basically making sure that these T's are the same, whereas this, it's like TU. Okay, I understand now. I understand. Okay, I actually want this then. Rec. Because I want the type to be the same. This is a higher restriction. I thought I was doing like some dynamic thing for some reason where it's like first it checks this, then it checks that, where it's like branching, but no, it's just, it has a compile time generic check to make sure that the two types are the same. Okay, I should actually change that in my other goob as well. Where did I do that? That's in the push solve. Checking those pointers. Boy, if you don't cut that out. Okay, so where is it? There it is. So I did... Oh, I selected the right one. Great job. Okay. Core. Okay. STD. Okay, so... Wait. No. It would land because I'm only checking. Okay, if I do beep bop bop, if I do what if it wants to replace face 0? Does that necessarily mean that face 0 is not on the Scoobert Dubert and we can continue the Dubert list? What if... Yeah, so we'd say like faces is like this, and then find is like this. So we could actually potentially have another one of these, but instead of replacing face 0, it just skips entirely and goes to the next iteration of the loop. Because it's what this is saying is I can't replace face 1, I can't replace face 2, I want to replace face 0. Face 0 is bad, it's not on the mesh. Okay, so don't try to replace face 0. So if we check the other faces, so instead completely skip the entire face generation. And then, all right, so we got the oof, and then we get the oof. Okay, so this is face 2, face 0, face 0. Bam. Okay, so if face 0 does not occlude or intersect the new intersection, then that means face 0 is totally irrelevant to the convex solid. Is that always necessarily true? Because, like, the faces could be unoptimal. So what it's saying is new face is a better face than face 0. But does that always mean that face 0 is not on the solid? I don't think it does. I don't know. Because if we look at the bowl example, like, we're trying to replace this face because we're trying to get 3 faces that form a point on the convex solid. So we're throwing out this face, but it is part of the solid. All the faces are part of the solid. But that's not face 0. I guess that's just from our perspective. Yeah, okay, so the check has to come after. It can't be here, I don't think. Okay, so this is like check if face 0. Oh, we need to roll through the faces again here. Okay. Check if face 0 must go. Who must go? Okay, so let's go face. Meaning it is a degenerate face and does not contribute anything to the convex solid. Don't you love it when you're just designing an entirely new algorithm and you don't even know if you have the right data and you don't know if the algorithm is going to work? Boy. Okay, so is that enough option faces? Direction of edge. Formed by face 0 cross face 1. Biggest abs. Who has the biggest abs among us? Sorry. So this is the second part of the algorithm. Okay, so we have entirely rejected the face 0. The Scoobert Doobert. So that's going to remain here. Oh. The denominator. Gosh. Reject this face entirely. Okay, so if you have multiple... Do I need to do deep, 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 deep? I think I do because it'll. So this not being greater or equal guards against duplicates, but derp, blurp, blurp, blurp. Why is there duplicates? So it guards against duplicates. That's great. Isn't that great? But I will still generate duplicates, faces. So like if we're going through the face list, if the face in this loop is the same as in the last loop, it'll have the same results. So it'll generate another of the same face, and like, don't do that. So I think we dedup. You need eq, don't you? Game? Oh, it doesn't know. So if we replaced some, or if it already existed, then instant death. Newly inserted. Oh. If it's not newly inserted. Got too scared of myself and used something that worked. What? How long ago was that? 6 minutes ago. Gosh, I've been locked in, I guess. What were we talking about? Oh, the algorithm not working, right? Just use something that worked. I I don't have a lot of experience like finding other people's code. I usually am just writing my own code. Holy. The names are crazy. So like what I'm trying to do is like if it's like that, that's nice how it highlights both of those. I'm trying to like if it's in view, if you can see it, then like yeah. Knew about BSB source. Temptation was too much. I see. But like it's not actually doing what I need to do here. It's not actually doing it. So what the hell going on? So this is oriented. No. Yes. If whoa. If I pick face 2 without absolute value, then it will be oriented. But will it remain oriented? So like it would like pick any face 0, pick any face 1, but then it does the cross product. So now you are oriented and you have some chirality, and then you find the best match for that orientation, and you start with faces like this. But when you like knock the faces away as you like do this repeatedly update face loop, does it keep the winding order? Because like I need to generate them in a specific order. Oh, do I? Wait. Do I need to? That's for the graphics. I need to. I think I'm a good idea. I think find the best oriented face. No.abs. Maximum dot product. So the minimum, it has to be abs because it's finding it close to 0, and like you don't want a highly negative one. You want close to 0. Whereas this is maximized. Okay, so it will be oriented in some way. I feel like it will remain oriented as it replaces the faces. But I don't know. Okay. I think it'll work. We are oriented. I am getting oriented. Okay, great. Solid. Who must go? Face 0 must go. Sorry, I already made that joke. Okay, follow edges around the face. What the hell? So, note that we chose face 2 so that the faces create a particular winding order. If we choose which face to follow, we face 1, face 2. It will always wind with a consistent chirality. I freaking love that word. It sounds so complicated. All right. A consistent face to follow. Chirality. Let me check my chirality. Okay, so think about it. Think about it. What the hell? So I just need to do this. Like literally, I just bonk this calculation over and over again. And that's it. This is just like bump, next one, next one, next one. Something like that. I don't know if it's exactly this calculation, but like basically we have to okay, I have the drawing. Okay, so no red, no green. We have the faces. Wow. So we're looking right here. This is our vertex. Isn't that just great? We have a vertex. So these are our faces. 1, 2, 3. And we have a chirality. Let's say this is like face 2, and we're gonna go in the direction of face 2. So it's always oriented face 0, face 1. So it's always oriented like that. So it might be like something, but it'll never be the other way around. It'll never be mirrored, hopefully, if my intuition is correct, which it might not be. Oh, so if we go like that, then what is going on? So the goal is to find this face. So we're following this edge, and we're going which burp keep which so which face has the next dot product? So it's like we want a dot product that's bigger than this one relative to the like direction of the edge. So it must be the so like if we follow this one, then it intersects somewhere over here, and that's great. But we would prefer this one. But we can also say that differently. We do have this point. I feel like I could reduce this somehow, because like we have like 4 degrees of fixed point widening so far, or not like repetitive, but it's like 4 times the precision. So if we use the cross product, which is double precision, and then we do a dot product with the intersection, which is 3 precision, that's going to make 5. And that would work. But I think that reduces to, like, we can use a different calculation, I think. Maybe I should just write it. Maybe I'll figure it out if I just write it first. Oh my. So it has to be bigger. Yeah. Okay. Think. Okay. Yeah. Do it. Okay. So So the dot product to beat. Whoa. Okay, yeah. So we do phase 0, phase 1. Did we change phase 1? We did phase. Okay, this was just the initial. Okay, cool. Okay, so edgedir is fixed. We may have replaced phase 1, maybe. So this is the measure. And then this is D equals D intersection is edgedir dot intersection. So unfortunately, this is a degree 5. I shouldn't say that. It's a Dubert. What is this? Ratio? Oh, goodness gravy. So we can do this. Num, then. And now it is a ratio 5:3, meaning it's like yeah, okay. I've gone up to 17 in my Strafe client so far. So 8 is not the biggest I've done. 17. That's a 1,100 some odd bit number. Okay, we're only using like 512 bits here. It's small fry. So now we loop the loop, do the loop, and we get this. Doop the loop. So face 2. Do we know? Tetrahedron. Think about a tetrahedron. So if you're on a vertex of a tetrahedron, you're always getting the other's face. And you can ignore face 1. So it's going like 0, 1, 2, and we're moving this way around the bowl. So can you always ignore face 1? Oh yeah, that's right. I had a clone and I was gonna like drop them as I went. Ha 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 ha. Because like as you go around, you've already visited the faces, so you can like ignore them. But like that's kind of an optimization, ignoring the faces. Really, we only needed to find two faces that were part of the convex solid. Um, but I don't know how to do that without a third face. So that's okay. I should stop thinking about optimization. All right, so now we're doing like a crawl. Claw. Claw. We're crawling across. So, I mean, is this worth it? Yes. No. 171. So it's not that bad. Like it's this algorithm is like O(n) squared ish. Because you got the loop. Uh-oh. So this is like, hopefully it only runs like 1 to 4 loops or something, and then it like goes, ah yes, I found it. So I guess O(n) cubed, it would be the worst case potentially with the loop. The loop. Oh my god! Why didn't DeepSeek write this code? Like, it should have just written this code. Why didn't it do that for me? Oh my god, bro! I can't believe it didn't write this code for me. Okay, so we get the bit all we need is a It's a It's like find min. I get filter min. Can I filter min? Do I want to do that? It's filter min, right? And it always exists, right? Unless you don't have a closed scosed solid convex solid, closed convex solid, it won't find. So if you have like 3 faces, that's like not a solid ever. You can't make a non-infinite solid with that. But it rejects it. But the 4 faces aren't guaranteed to form anything meaningful. It could just be like face, and then nothing. And then like it's just an infinite volume. So this is what it's like. Okay, this is the loop. So the loop, the loop. It's the loop. We need the loop. The loop. So we don't know how long the loop is gonna take. Bubbly boo bop 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 boop. So we could go in the direction of face 1, or we could go in the direction of face 0. No, face 2. So all we need to do is go around until we hit face 2. And then, or I guess the original face 1 actually. Actually what? Why can't I see it? My steam is running out. Where's my coffee? I'm only halfway through the algorithm. little bit of cheese. That looks like that's falling off. Bro, the dust. How? Why? Bruh. Where's your code, Rackpier? I haven't seen. Is your project open source? Where are you doing your things? No pressure if it's not. You can keep it closed source. Everything except the Roblox stuff will be. So you're just working on it in secret until you're ready. Switch the library to yours. Swap it out. Working in shame. I understand. Look at this shameful thing. What is that? What is that? What is that? What is this? I cannot believe this works. Like, I thought it was going to be like subtly buggy. I mean, maybe it is, but yeah, I was actually disappointed in Rust when I was writing this because the traits only work with themselves. And then like you can't specialize to have it so when the type is the same, it like does something different than when the type is different. Or maybe you can and I don't know about it, but I couldn't like get it to use ops. I had to use functions like mul ratio and like Lee ratio. Like, where is it? Where is it? Yeah, like these guys. I just want to use a comparison operator. But you can't do it, son. Which library do you mean? Do you mean my like BSP loader thing? So my BSP loader is generating strafe client stuff. RBX mesh. The RBX mesh is all good. It's published. It does it. It reads it. For writing too. For writing, you need to be more careful, but it does. You can't write Roblox mesh format version 1, but everything else has been right. GitHub. So, So this is the only one that you can't write because it's like text. Please don't try to write mesh version 1. Use like version 2 or version 4. Version 5 is insane. Yeah, so like version 1 is this like it's like decimal text. Why would you want to write that ever? But then look, BRW means you can read it and write it. All of these should have both read and write. So that the only thing is, the like vertex count stuff, you have to make sure you fill in those properly. There's no like helper, like I could also have like private fields and helper methods to like construct it, but I was only going to use it for reading, so I didn't do that. That would be a good pull request to have like safe abstractions for constructing it and like make all the fields private, and you can only build it safely. But it does have read and write for all of them. Does it actually work for physics mesh? I know it does for mesh data. I know I writ that. It was actually pretty hard, the mesh data, because of the obfuscator. Were you here when I was writing this? This was a fun stream. So look at this. The read chooses whether or not to use the obfuscator. And can you just right? So this thing doesn't have bin read. Should I have done that? Because like I could do this on the mesh data. So this is the write implementation. So you can just do mesh data write, and it'll do it. It knows whether or not to use the obfuscator for the file format. This is a sort of never file format. So you always use the obfuscator. This is there's no mesh. You can't have a mesh in this. It's not a mesh. It's a like something else. Physics data. Yeah, I'm not. So like if I could, I like to have this function so that you don't have to import this trait, but write, you do need to have the trait. So you need to like have bin RW as a dependency for write. Yeah, so this library is read focused because I am using it for reading. I didn't make it fully. I don't have the same level of thoughtfulness for writing, but it does. But I did want to technically support it at the very least. Should be good to go. What the hell? You have bin RW on this guy, but not on the. Not on the mesh data. So like I could do the same thing here where I have bin RW. And yeah, literally just this. I should probably do that. It's you know what? I'm doing it right now. I'm interrupting this program. We interrupt this program to write the mesh thing. I don't know. It's did I just delete all the code I wrote? Okay, I have Control Z, so I'm saving this right now. All right, so what I did, I think, is added it back to here. Where did it go? Oh no, this looks the same. So it was all the deletions. There's a big bundle of deletions somewhere. I have no idea what I just did. It was not good though. A bunch of code that was removed from somewhere got unremoved. I'm actually going to look at the stream VOD to see what that was. Is that apostrophe going to be a problem? No. Plain Sol 3. Okay, it's the extraneous gooberts. It didn't do what I thought it did. Oh, it's right there. This is what I thought I deleted. Oh, did I not actually delete it? I pressed stage. I thought I pressed discard. Okay. Okay, right. You have to press discard twice. Okay. Thank you, Sublime Merge, for being good. Okay. Public and good right implementation. Fear technique of a 50 megabyte Roblox XML file may be frowned upon by Roblox engineers. Just use the binary format. Yeah. Open recent mesh. It should be a non-breaking change, if I am not mistaken. The mesh. So if I go here, so this mesh data does not have been rude. I can go like this. Read Lee. And that's it. Excuse me. And then I can do that here. So impl. So it needs some special care. Wait, what? How? Okay. Oh. Okay. Stop it. Spaces. Okay. So then this goes here, and that should be it. Read. Oh, yeah. Okay. Wait. Oh, wait. What did I do here? Oh, yeah. Okay. Yeah. Not quite. Okay, so it's like this guy got right options. Who is this? Mesh data 4. Huh? I don't really understand what's going on here. So So do I go like this? CSGK read options? Is that what I'm doing? I think that may be what I'm doing here. Okay, that's why I was confused. Oh. So true. So true result. So true. Okay, I do believe... Oh. Header. Wait, we already read it. Haha, read it. So... So if we go like this, I think it's like... Okay, put it back, put it back, put it back. We want to do like this. Header read options. And then this guy is now already read. Beep, beep, meep, meep. But then so it's like something. I think it's just like this, and then we do like this. Boing. Oh, hold on. Actually, I think you can just do like this, right? Bin read options. So technically, you can go off the trait, but so technically you can go off the trait. Interesting. Do I like that better than saying directly mesh data 4, mesh data 5? Oh. Oh, 2. Haha, 2. I don't know. It's a little bit shorter. Okay, but that should be the thing. Oof. So now we have this for mesh data. So it's made more complicated because of the obfuscator, but I can still directly do it like that. And it doesn't actually change the public interface. It just implements this for mesh data. So you can read directly off mesh data, or directly, you can just write this code yourself. That's all it means, is that it's a little bit more full featured. Cool. Impl bin read for mesh data. Cool. Okay, so I just had that thought of like symmetry. This was off the table when I was writing in the library because like the obfuscator was obfuscating my brain. But now I see the whole thing. So like once I figured this out, I like had the full picture. And now looking back, I see that this is the same thing. So that's cool. Cool. Okay. Test. Gotta test it. Nice. Okay. Cool. Okay, so that's gonna sit there until the next release, if that ever happens. It's just like symmetry. The externally it looks the same, except that this value you can directly read it yourself instead of having to use the read version function. This is sort of like a convenience function, but it's also kind of odd. It's basically so you don't have to put the trait in scope. You can just call this function, and it already has the trait in scope for you. That's it. Cool. Did it. I did it. Yay. Okay. Back to work. Why is there error here? Oh my god, bro. So this is optional value. What if it doesn't? Then it's bad. Then we have an error. Conductor, we have a problem. So this is missing. It's like invalid something. Invalid planes or something. Yay. Cool. Okay, that error's gone. So much mental power to write algorithm. Oh, but this is the easy part. It's the easy part. Keep that in mind. It's the easy part. Easy, easy, easy. It's so easy. You can do it. It's so easy. I am made of cheese. It's cold. So we're gonna shuffle. We're gonna do either. I kind of like the idea of going in the direction of phase 2 and keeping phase 1. Yeah, so shush. It's the easy part. Oh god, the dot product. Good god. 8 times precision. Yeah. And then when we compare it, we double it. semicolon. Okay, so this. Oh, this is filter. Predicate. Filter. So filters, which ones pass the predicate, right? When given an element, true or false, the rotator will yield only true. Okay, so if it is equal, we don't want that. So if A, B, C bad, just like not. And are you allowed to do that? God damn it, Rust. That's so weird. It just lets you do that. That's so silly. Okay. So ignore faces we've seen before. So actually, we can go farther here and do filter map. Oh. And do this guy here as well. No way. So. Oi. What the hell was that? Do what I say. What the hell? Bro. Okay, so we are doing face 0. We're doing face 2 new face, I believe. Oh, we can't filter new face. Yeah, okay, so I'm going to say let face 1 equals face 1. Keep looping until we meet this face again. So don't filter that, because once you reach that, that's the end. Boy. So then yeah, okay, new face, great. So I can do question mark. So easy. So the game is so easy. It's so easy. This game is so easy. Okay, so that's great. Isn't that great? So this is true, false. That's amazing. Okay. Then next question mark. Map. How should I write this? Oh. So I have filter map. So I'm sum none. I'm giving the intersection and then finding the minimum. So min by key. So we go like, hey, what's up? Some new face new intersection. And then we go like, whoa, whoa, whoa. And we know, oh, question mark, so true, so true. This is so true. We can just, yeah, let's write it to a variable. It's more clear what's going on. Semicolon, and then else none, but that's kind of ugly. So this is 3 sum none values. 1, 2, Okay, actually I could untab this and put it like this. If I invert this, go like this, or bong, return none. Why, goddammit, return none, and then it like gets rid of it, and then we go like this, and everybody happy. Okay, so then this is not real. This is, what is that? Okay, so oh, so I also actually have to filter here more. If the new intersection, LE ratio, blah, blah. So we got D new intersection. New is this new intersection. So then if D new intersection is less than D intersection, then return none, because it's on the wrong side. So in our picture, what that means is we're looking at 0 and 2. We're trying to find the next face. We're trying to find this face. But what it means is we found this face and like, or like this face, and it's like tracing to like back here from the edge we're looking on. It has to be past this point to count. So that's why that has to be filtered out. Less than or equal to this. If it's equal, it is also invalid. It must move forwards. Do we want this? No, we don't care. Wait, do we? Right, the algorithm is doing the business. Good God. D. So all we do is D. Is that allowed? No. Okay. My face. So if we go like this, is that allowed? It is. Okay. So we throw away the face, but then we get the face here. So this is, we don't care what the D was, but we do care what the new face is. I love min by key. It's such a wacky, like oh my goodness. Reduce fold, bruh. Oh my God. Damn. That's crazy. It's like, it's there's quite a bit of code to it. And it's like repeated everywhere. The D value must exceed the it. I don't know. But so it must be larger, but we're finding the smallest of the values which are larger. Classic algorithms. Okay, so we have a new face. So this is, if we don't find a face, the algorithm is throwing, and we can just leave instantly, and like the algorithm has failed. Because like it's not a tetrahedron or something. So the new face is a new face. We have the new face. It's a new face. What? Okay, we actually need the intersection as well, out of here, because we're moving. Intersection. Yeah, new intersection. A little bit insane algorithm, but it's okay. So the min here. Can you min a ratio? I thought I had to Lee. T. Oh, is it using ORD? Oh, okay. ORD is self. Okay, it's doing ORD. So the ORD implementation is using Lie ratio. Okay, that makes sense. Good God. Okay. Cool. What was I thinking when I wrote this? Find the next face. Literally just find the next face. Moving, let's say clockwise around face 0. So we make face 1 immutable, then mutate face 2. So what we do, what do we do? So we go, yes, next. I can omit one solve calculation here, but it's only one, and I'm doing thousands. So like the point that we have already, the intersection point, the current intersection point, boing boing, this guy. It's a vertex. We could add it to the list. Excuse me. So we could go like, actually we haven't modified it yet, so we can do that here. If we put it at the top of the loop, push point onto vertices. Okay, good, definitely good, for sure. So faces equals vec new, and then We can avoid this until here. Yeah, so let face equals vec new. Follow edges. So we're building the face now. Oh my gosh. So this is if faces is empty, then none else. Faces with an okay, do it. Good. Yes. Actually, is that an operation? Is there like a map? Well, I guess you could do is empty then. That would work, but meh. Actually, that would be nice, wouldn't it? Because that would look like this. Oh, but I have to invert it. Is that clear? I think that's like less clear than what I had written. Okay, faces. Wow. So we go like right here, faces dot push face. Wow. And then right here, we do face dot push. So now we have a giga huge number. We need to like make it a real number. So intersection dot divide dot fix 1. So we're taking the 8y number, doing the actual division, and then truncating the precision. It's represented as a ratio. Okay. So push the point onto the vertices, and then at the end here, if we find face 1, then we're done because we've already pushed the intersection we found should be the same as the first one we ever found. The new intersection should be the same as the first one we ever found. So break is that right? Break face. So break your face breaker. That's the outer loop. So we're done. We looped back around to face 1. We're done. Otherwise, face 2 equals new face, and intersection equals new intersection. Bing bong! No! Oh, did I? Oh, yeah, no, you're right. You're right. That's it. That's the algorithm. Next. Done. Go next. Oh. Is there any chance that this frickin' algorithm works? I say no chance in hell. This is so complicated. There's like I've sort of assumed my intuition is correct multiple times during this. It's like, oh yeah, the chirality is gonna stay stable. Oh yeah, that'll work, I think. Well, I need proof. I need mathematical proof. Bruh. Oh my god, bruh. Wait. Uh-oh. Face list. Oh, no, it's not question marking out of the whole algorithm. It's question marking out of the filter map. Okay. Bruh. Ignore faces that are part of the intersection. The edge. Current edge. Ooh. We got an algorithm. Okay, what if there is... What if there is a face that is exactly equal to face 1? I think I might have to deduplicate ahead of time. But that's... It's not that big a deal. But that's... that just means like... I don't allocate twice, man. I don't want to allocate twice. How efficient is it to iterate over a hash map? Is it like samey same, or do you have to like be special? Oh my god, bro. Because like faceless may have to be a hash map instead of a WEC. Because that would fix the dedup here as well. All right. Iter. Iter. Base iter. Uh-oh. Why is it not giving me a thingy? All right, shut the up. Dedup.iter. Tell me. I want to see. Why can't I see? Oh, iterating over set takes O capacity because it internally visits empty buckets. Okay. That's exactly what I wanted to know. Kind of. I wanted to know if it's like a little bit more expensive because like this iterates a lot of times. So let's dedup ahead of time. Oh, it's actually pretty efficient. So hash set. Oh my god. You good? Chilling. Absolutely chilling. Okay, so then can we like know what it is? No, because of this. That's right. Okay, so we're collecting into a hash set. One allocation. Deduplicated. Okay, so we deduplicate ahead of time. So there cannot be an exactly equal face, which would make the algorithm fail at that point, this point. It can't like find a face that's identical to face. Oh, Wait, haha, I could actually do double equals instead of pointer eq, couldn't I? Interesting. Um, I mean, it does a lot of looping. It might be worth the allocation or the hash setting. Deduplicate ahead of time. Still only one allocation. No allocation. Let's go. Oh, well, no, I guess I'm constructing vectors. Oopsie. Oh, does it? Is it? Did I do it? Did I do it? Is it gonna just do the thing that I wanted to do? It's probably gonna break. If we're being honest, it's gonna infinite loop or crash. That's what it's gonna do. Because like the assumptions are not always perfect. Okay. What do you say? What? Invalid planes. Okay. So everybody has invalid planes. Nobody has valid planes. Except invalid planes. Yeah. Okay, what about Arcane? I can't believe it made it that far. It ran something. All right, well, it looks like nobody has valid planes. Okay. So one of my question marks is destroying the entire world. All right, let's expand the optional value into a result so we can have different variants depending on how it fails. What did he say? So we're going to go over here. We're going to do brush to mesh error. We're going to zoink this, and then we're going to go like, oh yeah, no, this is actually for this guy down here. I'm going to paste that anyways, so. Zoink. Okay, so now, planes to faces error. Planes to faces error. Wow. Yep. And instead of result, it's a result. Instead of an option, it's a result. So now, instead of the question mark, we do for each one. So init face 1, I guess, and then init face 2. So instead of like this, it's like okay, or error, planes to faces error, init face 1. And then this is planes faces error, init face 2. Initialize phase 2. And then init intersection. Boing. Where is it? There it is. Do it. Intersection. Okay. Great. So then possibly it's one of those. So who is this? So this is like so that one is like find new intersection. Find new intersection. Huh? It's like here. Oh, wait. There's none between. Betwixt. Find new intersection. And then that is the last type of error. Oh my god. So then the last one would be empty faces. Which I think that's the most likely, is it's just kind of not working at all. Okay. So then now what I can do is I can say this is a planes to faces error. Wow. And that should be map error. And then noise. I didn't actually do anything with the faces, but that is okay because it's throwing an error. Create failure mode variants. I don't know. Create error. Cool. Okay. Do it again. Okay, what did he say? Init intersection. Well, that's informative. So when we go face 0, face 1, face 2, it goes, that has a 0 determinant, and it doesn't do anything. Huh? Is this wrong? Do I not want the minimum absolute value to get, is that how dot product works? When the dot product is 0, they're perpendicular. I want perpendicular. Okay, and then I take the cross product, and then I take the dot product, find the maximum along the edge dir for the p-value. Okay, print. How do I do this? Phase 0. Did I put debug on this goob? Nope. Debug them. Do it. Oh. Help. Okay. All right, what are we looking at here? Forgot about that. It's all like whack. So we want to like pretty print. So let's put them out. So we go face 0 dot normal. I think I do something wacky when I print it. We'll see. Be a little bit more discernible. It's like I converted to like decimal stuff. All right, what do you got? Yay. Okay, so that looks great. That looks fantastic. Oh, am I Valve? Oh my god, dude. They're normals. Ah! I'm doing the Valve stuff on the normals. Silly boy. Okay. You don't need to scale your normals. Oof. Silly boy. Okay. Did I cut? Oh. Do I want that whole goobert? Whatever. I'll just paste it. It's got to do something. All right, so the normal vectors are normal vectors. Constant valve factor, differing player sizes. How is your valve factor calculated? It is not calculated. It's just a constant. Like I could have, you could supply it somehow, sometime later. It's just a constant right now. Okay, so that's fine. Oh, wait. Was that making the value less than epsilon? 62.062. Cubed. If we do this value, power of 3 less than 1 over 2 to the power of 10. True. Okay, it was less than the epsilon. Yeah. Okay. So the normals were not normalized. So that, like, I am doing an exact calculation here, so I don't actually need an epsilon. I can literally solve it exactly. I literally am solving it exactly. So like, all I care about if it's exactly equal to 0. Any other value is valid, and it will exactly calculate everything. So we don't actually need an epsilon. I think. I am doing exact calculations, which is pretty cool. I can also use a starting width that's wide enough for all floats. You only need like, what, 128 or something, or 256? it would the calculations would be massive, but exact. Okay, I think we hit an infinite loop. I think we hit an infinite loop. That right there, that's an infinite loop. It's cooking something. So that looks like an equilateral triangle. Cool. Nice. Don't val transform normals. We are doing exact calculations and don't need an epsilon. So, the only problem with that is if it finds a vertex that's too far. I guess I should use the try fix. Let's see. So if it could calculate a vertex that's too far away. That's the only problem. So do I have like other methods? Try. What do I have? Extend. Okay, let's dive in. So I know that I have don't look. What? Oh, this is linear ops. Right. It's diving into the other guy. So, paste. So, we want to go to this. And we want the impl wide, same size, not const generic. Beautiful. So I have these like 3 operations and I don't remember what they're called. Remember I said it's upsetting that there's no const generics? This is why. Oh, it's square root. This is like basically the bottleneck for the entire physics is this algorithm here. If you make this algorithm better, you're cooking. You're gaming. Square rooty. Widening mul. Yes, very nice. Wide mul, wide div. Didn't I have... Is it a branch? Where is the code? Fix. I don't see it. Did I never merge it? Do not use epsilon. Okay. I need to like check the branches. Let's go to the goobhub. Next, fixed wide vectors, branches. don't think this is the rice branch. What is that? All right, you know, I'm gonna open it into the Goob. Okay, open repository. That one, that one. Uh-oh. That one. There it is, width convert. Why didn't I? Okay, so this is the code that I wanted. So like, okay, so this, why didn't I merge this? This makes the distinction of how you want to truncate or how you want to change the width, right? So there's 3 types of operations, or wait, I guess there's 2 types of operations. So if you're going from a 64-bit number to a 32-bit number, you can just truncate it and drop all the high bits, and that is wrapping. It's like you've done a modulo, right? Or you can clamp it, and that's like if it's above range, then you bring it to the maximum value. If it's below range, you bring it up to the minimum value. But I guess you can also have an error. So try into will attempt, this is such a mess, but because of the no const generics, but this will try to, this gives you 3 options. You can error, wrap, or clamp. It's very well thought through. I'm happy with this. I don't know why I didn't merge it. Right, because it changes all the names, that's why. And like, I already wrote all the names everywhere. Boy. Oh my god! Okay. It's not pretty, but the idea is good. So this is what I was thinking, like, I could like, check if it's in range first. The pyramids discovered. The ancient pyramids. The macro. Oh my god. Don't look. All of it would vanish with const generics. Oh my god. Fix 1 equals 2. Oh my god, bro. We don't talk about the 1 equals 2. Yeah. Okay. So that's the only problem is like, problem. This may push a vertex that does not fit in the fixed point range, is thus meaningless. Oh my god, bro. But I never wrote it, or I never merged it. Because like it would change all the code to like widen, narrow, fix, bruh. Okay, where are you stuck? There is multiple infinity loops. So baba bee. Okay, agua. Oh. I think it's right here. So I think it's like alternating back and forth. It's in an infinite loop, and I need to have the ignore list grow as it checks more faces and does more loops. I think that's what is going on here. but I should be able to do it the other way around. I should be able to clone the face list and then shrink it or something like that. Oh, holy smoking donuts. Wait, literally, I can clone drain here. So for new face. Huh? So I could go like, let me just see if I'm insane. Oh. All right. I'm gonna not print right now. Save. Okay. So we're gonna clone every loop. Oh my god. You're gonna clone every loop? But whatever. Okay. Let clone every loop. Let me just see if I'm insane. Is face list dot clone? No way. Wow. Why? Wait, really? Oh, you need face clone. Okay. Cloak. Spell! Okay, so we cloned it, and then we just zoink it. So we do like, oh, mutt. So true, mutt. So then boing dot remove face 0. 1, 2. Oh my god. And then this is, that's it. You just check the others. Nar. So is that allowed? I think so. Okay. Yeah, so you never go back ever. So we can do like this, I think. I think that'll fix it. Temporary value dropped. Oh. True. So I think I want iter collect. So I want a list of references. So I can zoink the reference to the original. Oh my god, bruh. So does it need to be a hash set? So like, oh, filter. Easy. So easy. It's so easy. It's so easy when you're smart. Okay, filter. When I play it smart. Okay, so give me. All right. So it goes like filter bop face. Filter face. New face filters on Instagram today. Great job, team. So isn't that just great? I think this is gonna. I can just. It doesn't need to allocate. It can iter filter just whenever it feels like. But we do need face 1 here. Yeah. Let's call a new face. What? Okay. Arguments to this function. So true. So that's the benefit of eek. Okay, what is about to happen here? Does not need to be. That's so true. So true. Okay. What do you want? Moved every loop.
I had the wrong mental model. Dang, I thought it was. I mean, we still only need to allocate once per face, but. So this is a I think hash set. And then we do actually have to collect. And then we don't. So we iterate like this, but then when I do this, I remove it from the gap. Just like I said. So like, I do need mutt. Oh crap. Is that allowed? I think the borrow checker might figure it out. So if I go like remove, so we have it borrowed right here, and then we want to borrow mutable, but I think it'll figure it out. I think it'll figure out that we're like going out right here, and it'd be like, sure man, whatever, I'll drop the borrow. Okay. It didn't figure it out. Okay, immutable orb later use here. Okay, so like, you're telling me if I just go like this, then we're chilling? What? Does that hate me? No. Okay, so okay, it was just the wrong type. Okay, I was right. It does figure it out. So it's immutably borrowed, and then I try to mutably borrow it, but I'm dropping it right here. So it just figures out it can do it. It just figures it out, and it's nice, and it's Rust. Yay. Okay, so this way, it doesn't ever revisit faces it's already got to. Gap. But we still have infinity loop over here, so unused. Clone copy. We don't actually need that, I think. Oh. No revisit. Good enough. All right, Surely I know what I'm doing, right? Busted algorithm. It's busted. Oh! Okay, what is the new error now? Find new intersection. Okay, we are no longer going through infinity. Holy smoking donuts. Okay. Find new intersection. Okay, we got it. I was right. It was doing that. I had that in my head when I was designing this originally, but I didn't do it right. Do you think it'd be faster to just clone the hash set and then remove? Is a hash set, can you like mem copy when you clone the hash set? Clone. How deep is a clone of a hash set? Can it be made very big fast? Okay, clone. Who knows? just calls that. Bruh. Okay, so where is the guy? Hash set. All right, can I see who this is? Please? Why don't I have an IDE? So, is it like at the bottom? Hash brown hash set. Well, that's helpful. Okay, well, let's go find it. Hash brown. Do we have a hash brown? I do. I already have it. Okay. Hash brown. We'll get the latest and greatest. And then check it out. All right. Hash set. Looks like I was looking at it before as well. Okay. Clone. Was I literally looking at the exact same thing? Interesting. Hash builder clone. Hash builder. That's not what I want. Table, raw table clone. Go to implementation. That is not helpful. Raw table. I just want to know if it's doing like memcopy or if it's doing like hash. Because like if it's just doing hash, then I'll just keep the code. But if there's a memcopy and then I can remove it with only 3 hashes instead of n hashes, that is better. Oh my god, bro. Hash. Bro, okay, clone. Cloning all elements. Hash brown scope guard. Clone. Iter. Okay, it's just iter clone. Okay, so it doesn't hash? So like it's cloning all the goobs, but in my goob I'm also hashing all the goobs, which like doesn't matter in the slightest, and I'm getting all concerned about nothing. But isn't it nice to think about performance. So like instead of filter collect, I could also do clone remove, right? So I was just wondering like how good the clone is of a hash set. And like this is also doing all of these per item, whereas clone remove would like just do 3 extra things. I feel like it's better to clone remove. Why don't we do it? Just give it a gander. So clone, doink, and then yeah. Oh my god. So bruh. So I think this is faster. So then this requires clone copy. Uh-oh. Right. I was doing that right. I do actually need references. Right. I do need references to the original list. Interesting. So I can't actually do this. Because I'm not actually cloning the hash table. I'm making a new hash table of references to the old hash table. Okay. So this actually belongs here. Drain a hash set of references to the original list. I can actually do this. Face refs. It's like remaining face refs. Okay, well, I think that's kind of the best I can do. Clarify and comment. Cool. Just cool. Okay, so now the algorithm is failing on find new intersection. It should always be finding a new intersection because it's just. Wait, does it fail? Does it fail on every single mesh, or is it just some of them? Because if it's like not enclosed, then this can fail. That makes sense. But otherwise, like, oh, the algorithm. Yeah. I'm getting winded. I wrote the algorithm. Can celebrate that. Okay, so is it solve fail or is it this? Okay, so none. Okay, this is like a filter, and then this is the find it. But if it always returns none, that's bad. That's bad. So the new one less than or equal to the... Oh, is that just totally wrong? I think it's totally wrong. I think I just have it straight backwards. Okay, so... Oh no, oh, is it return none? Okay, okay. So if this one is less than or equal to it, then dump it. That's correct. Okay. Oh, let's look at the common implementation of integer here. So this is showing off my fixed point stuff. So this is I have this like wrapper module because I don't have default values for the vectors because I don't use num traits. Like identity and like 0 and 1 are hard because I can't do that on an arbitrary type. There's not a 0 value of any arbitrary type, right? That's why the num trait crate exists. So you have a function to get a 0 value from an arbitrary type that implements the 0 trait or whatever they have. So I have this sort of like nice default values little wrapper around the various fixed wide linear ops things to like name it the same. So like planar 64 vec3 was the old name of the fixed point type before I made it self-widening during multiply operations. So that's sort of a compatibility interface with the old library. And so yeah, this is like my interface into the fixed point stuff is I have all these like default values sort of that I can like nicely access. And like that's sort of what's missing from a vector library, but you can't do that without num traits. So yeah. I just thought that this is like an interesting crossroads of like it's kind of a cross section into the library of like how do I interact with the library? Everything in my code goes through this, and then this is the has the library as a dependency. Yeah. Well, actually, not everything goes through this. I do directly use the fixed point type in many places. Triangles. This guy. I directly use this type. Buh. So like you can have 0 and stuff on fixed point because it's a fixed point. But for some vector of some type t, you can't do it. You would have to have the trait thing, and that's like, it's a trait. And I also didn't want the things to be interdependent. Did I succeed into that? Optional. What did I do? So if it depends on it, then why not just... Oh, right. So this is for the like, the changing the... It's the clamp wrap, except I don't have those functions. It's the changing the bit width functions. It's basically like convenience, so you can call it on all the sub functions without needing to do like map fix, which like changes the precision for each component. It just, you have a one function that does it on the whole vector. So if like I could take advantage of this and like make the 0, 1 values and stuff. Paste. I tried to be thoughtful when I was writing this, which is always nice. Oh my god, bruh. Bruh. So it's failing here. One of these guys, either it's empty, the iterator is empty. Why don't we, I'll just print. I'll just go like, all right. Ouch. My stomach hurt. Ouch. Success. What did he say? Oh, that's something else. Ow. So it's always failing, but not always empty? I guess it is looped. So we could say if it gets here, huh? Huh? I don't know. I'm having trouble working it through my brain. After all that. Okay, so sometimes it is like doing things and then it stops doing things. So it goes like, oh, we found the vertex. We found the vertex. And then it goes like, ah. Doesn't that work? Okay, imagine like a dodecahedron or something, and it's like got a lot of faces. No, I think it still works. I think it makes sense. Like what this is doing, this loop right here, this is like testing all the faces. You have a line. So what the hell's going on? So let's look at the diagram. Amazing. So we have please, we have phase 0. This is phase 0, and we have phase 2, and we're looking for this face. We're looking for it. And we're sort of shuffling around the outside. What is this? This diagram is a bowl viewed from above. It's a 5 polygon bowl viewed from above. So we see the bottom of the bowl and the sides of the bowl. And I'm trying to collect the vertices around the bottom face in this diagram. Okay. So if you imagine there's more stuff going on, dodecahedron. No way. Oh, that's, I mean, it'll do. So there's more stuff going on. Actually, this is 2 bowls. What if there's like more places, right? Icosahedron. So what's the setup? So the setup is we have the bottom face of the bowl, and then we have the found face that we know is part of the convex mesh. It's not some like degenerate face that's like just included for no reason. We determined that in the first part of the algorithm up here through a lot of hard work. So now we're just kind of going around the edge in this loop. And this bit is finding the next face in that shuffling operation. So how does it find that? So we have the master face list. If it's not face 0, face 2, so this is face 0, this is face 2. If it's not one of those, then continue and keep checking. So we find the intersection point with face 0, face 2, and whatever face we're testing. That's an intersection point, and that can possibly not exist if it's a degenerate face that is exactly parallel to face 0 or face 2. And so that exits right here if it's a degenerate face. We continue. So what is the D value? So we have face 0 and face 2, and that forms an edge. And the test is what face intersects that edge farther along the edge than the last vertex we tested, but is the closest to that vertex. So we want the minimum, that's why it says min by key. It's the minimum dot product, D value, of the edge direction. So that's the edge direction. The minimum dot product along the, oh, is my cross product backwards? My cross product could actually be backwards. That would do it. Anyways, it must be, so we have your 2 faces. You have the last vertex. We know where that is. That's right here. That's the last vertex is here. It's farther along than that. Do you normalize the vectors? No, I'm using the full everything. I'm not using like, no, I don't. So it's farther along the line, the edge line, but it's the least far along of all the planes. That is the next one. I don't think that's wrong. Let's try this and see if that works. Oh, I could also swap the solve, I think. All right. Oh, does that literally walk in the opposite direction? That might actually literally just walk in the opposite direction. I don't know for sure though. Well, I don't know. Why does it do that? Why does it do that? Why is it doing that? What if I swap these? Swap. Isn't it the same? Doesn't it? Yeah, it's literally just finding the intersection point. It shouldn't matter. Crazy, crazy, crazy. I have no idea. I have no idea. I don't even know if my algorithm makes sense. Wait. Oh, I don't. Do any succeed? Hold up. Wait. It could be that some of them are actually succeeding. Let's go look. Go look. Where is it? Okay. Bra, me, eh. Okay, so how many me? Okay, I just built an empty mesh, right? Nice. So we want this minus this. So we're gonna look for that. Does any succeed? Because that would be a huge breakthrough. Because it could be that there's just a bunch of invalids. I'm not even generating anything off this. I just like craft the faces and then throw them away. But all right, what is it? Hey. Oh. Is it by accident? There's 3. Okay. So the algorithm runs the completion 3 times. Can I guess we'll see. We'll see. Okay, so it runs the completion. Okay, it runs the completion. Isn't that fantastic? Okay, where this one? I need this. Okay, hello. This is the guy. So this is I calculate it and I throw it away. Okay, polygon list. So I have faces. So that's just a list of lists of vertices. I think I do it like this. Polygon. I don't want to type. Equals faces dot into iter. Hello, iter. Map face collect. So it goes like mesh builder dot vertex ID model vertex. So then we do let pause equals mesh builder acquire pause. It's a double iterator. It's a double. We do more. Face dot into iter. Map. uh, pause. For real. And then close, close, collect. Definitely no semicolon. Pause. Normal. Ooh, I don't like that. Let's ignore it. I think it's just ignored, so. I guess I could just do this. Oh, I see. My little interface. Okay. So normals are ignored by physics. Oof. Oh, I generate the mesh. So it does not make graphics. So but be boop be bop that is huh? Huh? Oh, you know, that's totally wrong. What are you smoking? Okay, so we do the same thing? We do like, hey, I'm the graphics. Graphics. Mm-hmm. And then graphics. Wow. And then render. Okay, so isn't that just great? Isn't that just great? So we have 3 examples. And I want to render them. All right, so I'm going to do this first. Oh. Should I scratch pad show physics? So I need this on top of this. Buh. What? Oh. 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 Yeah, that did not like that. What is that? Yeah, we don't do that. So we got brush flag. Yeah, so it's adding the rendered scoob. And brush flags. Could do. Cool. Okay, so I stop render all else things. Now I render hello other things. So, do it. Cool. Okay, it's a comment now, so now I can do, huh? Ah, generated brush models. How about with a capital G? Okay. Neat. Oh, burrito. Okay, so it should draw nothing but generated brushes. So if I look around and I see something, then we can see what happens. There's a chance it just makes a giant triangle in the sky somewhere. There's also a chance it makes nothing anywhere. Well, I mean, it's making something somewhere. Kind of what I thought would happen with only 3. Wait, 4? Wait a minute. Okay, what if we try this one then? Oh! Oh! There he is! What? I can't touch it. Oh no. Well, well, so something doesn't look quite right with the generated mesh physics. My brushes are looking at like right now. So you're telling me I made this whole algorithm well, my stuff is open source. I did write it in this module, and this module, the BSP loader, is permission hereby granted free of charge. So if you want to steal the code and use the code, you are allowed to do so legally. You're also allowed to contribute. That is also legal. But I don't know if I'm even doing the right thing. I don't know. So this is the function here, brush to mesh, that I think is doing the thing. I have the brush, I have the BSP, and I get the sides range, which is supposedly a range of brush sides. Which supposedly I can get planes from the brush sides. Each brush side has a plane. So when we used the displacement info before, it was just like a flat nothing. So we don't even know if the brushes actually have lots of stuff. How many brushes are there? There should be like multiple thousands. Let's just print how many brushes are there. They do. I don't know that for sure. I haven't seen. I don't know the format. How many? Tell me how many. Wait, it's non-deterministic? No! Ah, I printed it at the beginning. Oh my god. Rust. All right. Okay, yeah, that makes sense. 4,000. That's in the right ballpark. I think the generated brush models are. Oh, this is a different map. Okay. So from my understanding, plane is only for the binary space partitioning. So it possibly is just meaning like kind of a parent node type business for the brush, where like I exist within this node or something like that. I don't know why you would do it as plane and not node. Because like the BSB also has node, but like why would you have BSB planes and brush planes all in the same list? I guess they're planes. I mean, you could do that. U16. Oof. Boy. Freaking brushes, man. What the hell is a brush? I wrote the whole algorithm. A brush is a union. CSG. But how? What? Toi? Toi? It's crazy. I love how the algorithm doesn't break on the init anymore. That's super cool. That probably means that the init works. So like the find first edge stage, this stage right here, all this code presumably works, which like, wow. If it does, it might not work. Why follow face edge code not work? It kind of looks like we're generating garbage or like we're reading garbage. That's kind of what it looks like is going on, you know? But, okay, we did see that cube. We saw the cube, actually. We saw it. We saw the cube. It was a cube. There was a cube and we saw it. I looked. Oh. Pfft. I found a bug. Okay. Let's try that. Oh, we got a new infinite loop. Infinite loop. Infinite loop. Infinite loop. The behavior is different. Yes. Okay. So why is it doing an infinite loop? Oh my God. We could try the negative cross product thingus bingus. Let's try a negative cross product, see what it does. Actually, you know what? I'm just gonna do this first, because like that's a bug. We probably still want this. No, no, no. All right. Sure. Negative. What else? You know, this. It's the same. So like, it depends which way we're walking. Min by key dot. So it doesn't it just change the direction? Because it's just finding the. Yeah, just that's literally just the chirality that's going around. Like it either goes clockwise or counterclockwise relative to the stuff. How's it going? I don't really know. I wrote a big freaking honking algorithm to convert planes to a mesh, and it does an infinite loop. Oh! It's just, what is the memory usage? Is it like going up? It'll be like slowly going up. Who did this? Okay, filter, what's it called? Strafe. All right, memory. It's going up. So it is now finding the new face, but it does not stop. Why did that change? Shouldn't that only affect which direction it's going? So when I didn't have the negative value, oh, I didn't have the prints on, did I? So it'll probably do the same thing. Okay. Let's see. Nice. Okay, so it does do the same thing. I think it just goes in the opposite direction. Let's do pointer something. Why don't we print like pointer arithmetic? Oh, I have to get like the item count from whatever. I'll just do it. I don't care. Okay. Index equals. Do a little bit of pointer arithmetic. Can you do like face list dot pointer core PTR. So I just want like just like just tell me. So that's a pointer. I don't know, minus. Is that allowed as sub? I think that's a unsafe. Cannot subtract. All right, dot. Hold up. Cannot take the address of a temporary value. So true, King. Okay. Dot sub. Can I do as usize? Okay. So I actually want this way minus that. Did I do it? Is it gonna break? I don't know. And then I can do index divided by mem size of mem face. Surely. What do you want? Never used. That is so true. Okay, well, hopefully that tells me what index it is. So much for using that. So it'll probably be like, it'll probably just break. I probably just did that wrong, but like, whatever. What? Oh, is it over? Yeah, I guess so. So that still has meaning. That means that it's like always the same value, right? I guess I don't really know. I don't really know what I'm doing here. Yeah, I assume that the face pointer is, oh, this is a hash set. Oh. Yeah, no, that's not continuous memory. What am I doing? Huh. Interesting. Huh. Does that matter? No, it just has to loop through it and like it just has to check that it's not going back over the same thing. So This is returning the same face every time? So it does face 2 equals new face. And then it, okay, is this wrong? If new face is equal to face 0, if they point to the same value, they're an equal pointer, then filter it out. We don't want to go back to the same one. And we also check that for face 2. So how would it be grabbing a new face that's the same? I don't understand what this print is talking about. Let's see if it's what I think it's doing, what I think it's doing. False. Okay, well that makes sense. False. Okay, what about this? False. Whew. Okay. Break. So is this good? Oh. Oh, hell yes. Oh my god, the cross product automatically picks the chirality correctly. Whoa, that's so cool. That's so cool. I'll always get the same. It doesn't matter if it's wrong. The cross product will flip it to fix it. That's so cool. Okay, wow. That's cool. So I actually don't need this to be no abs. But I'm still gonna choose it like that. Sorry. So what? Why is it? Is it the same face? Okay. What if we just like say, tell me about it. Adder, new face. What up? Pointer doesn't implement. I don't care. Just print it. Are we finding the same face every freaking time? So I don't know if that's like a pointer to... I don't know. Why would it do that? That doesn't make sense. So like if it sets face equals new face, is it breaking out here? Face 1, new face? I don't know. No. So it's not breaking, but it sets face 2 equals new face, and then it goes to the next loop and it finds the same face again. Okay, why don't we print the face instead of the address of the face, because maybe it's cringe for some reason. No. Wow, huh? Isn't it a face? It's a, oh, what? Oh, face, new face, you goob. Alright. So maybe the address of stuff was total BS and I have no idea what I'm doing, but we will know if we see that the face it finds is the same every time. Okay, so the stuff I was doing was BS. Okay, so it's not finding let's does this mess with it? So I could change all of these to double equals. And it would work the same. I might just be stupid. Okay, what was the face 2? Face 2? No, face 1. We want to print face 1. So probably it'll match one of these. But I'm doing something goofy with pointers that I don't understand. Would you look at that? Oh, 541. What? 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 Huh? 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 Okay, this is the degenerate face. New face is degenerate. So this makes sense. This makes sense. So what's going on is there's two faces like this that are exactly parallel. And it's like it's on the green line trying to find the next face, but there's two of them, and face 1 was a valid face that was not degenerate, and the face that it's finding is a degenerate face, but it's a better degenerate face. So does that make sense? No, shouldn't it be the opposite way? Shouldn't it always find face 1? Because like, look. If you imagine, so this is the face right here. What is this? This is a bowl. We're looking at a bowl from the top, and it's a low poly bowl with 5 edges. It's like a dodecahedron. It's like a half a dodecahedron or something. So we're trying to find the next face, but there's another face that is parallel to it. That's a degenerate face. But the degenerate face should be worse. It should find face 1, not the degenerate face, because it's farther along the line. It's more out, but we want the closest one that's above. So we want the minimum that's above. Does it mean that does it mean that it's like on it? Does that make sense? On it. No, it doesn't make sense. It would be none value because it would be solve none. It would be equals to 0. We're doing exact math here. I should not be getting this answer because it should the face 1 should be better than the new face that I'm getting. So I'm getting new face equals this. Oh, it could be the other way around. Excuse me. It could be, it could be that the new face is actually the better one. And the face 1 I originally got was degenerate and was not on the convex shape. And it was wrong. So, okay, okay. But it would have found that. It would have found that the original algorithm up here goes like, and it finds the best ones. So we go like, I want to find 3 faces. Finding the first edge. I want to find 3 faces that form an intersection, and that intersection is on the convex shape. So if there's any other faces that occlude the intersection, then I know that the 3 faces that I found are not on the convex shape, and I have to choose a different one, the intersecting face, basically. And that's like, so I start out with some clever choices for the initial faces, and how I do that is I choose the most perpendicular face to face 0. As face 1. So that's something that is, it's best to be perpendicular. And then face 2, I choose the most perpendicular to both faces 0 and face 1. And that's to start the algorithm out so I don't end up with like degenerate faces that are all flat with each other. It's the most likely to have non-collinear vectors because they're the most perpendicular. The biggest dot products. Okay, and then I find that intersection of those initial guesses, and then I make a bing bong of the remaining faces. I remove the choices from the list. So this is like the rest of the faces that aren't face 0, face 1, or face 2. And they are references to the faces in the original list. The original list owns the faces. And then it does an iterative process where it tests to see if the current intersection is occluded by any face. And if it is, then it's not actually on the Polygon, the convex solid. So how does that happen? So that's like if the new face normal dot the intersection is greater than the plane. If it's I gotta think about this carefully. Is that wrong? Plane dot greater than intersection dot. I think it's so. What is this? If the plane dot is greater than the intersection dot, then is this backwards? This could be backwards. I could be doing it totally backwards. Why don't I try it? Greater than, less than. Oi. Could just be entirely backwards. It's a little bit tricky to think about. So it might actually infinite loop somewhere else now because I changed it. But if it's not getting rid of the degenerate faces, then it fails like we saw. Okay, what did it do? Empty faces. Generated brush model 0. Okay. Okay. I forgot the den. Den is a negative. You can't. You can't. Self-own. Self-own. Okay. Self-own? What the hell? Okay. So when you divide by a negative number, it changes the thingy, and I do that in my library, which is why you don't see this in any code. I don't do .den .num. Can I do like one Lie ratio or something? Oh wait. Oh no, it just does that. LT ratio. Where the hell did my Scooby-Doo go? New face. LT ratio. Face divided by den. So I have to keep the ratio together and then use the provided dubs to know what to do. That's kind of cringe. Okay, so unlucky. Because it has to take into account the parity of the denominator. Because if it's a negative determinant, then that flips it. So I believe that is a problem. Okay, so then this is actually, I think it's flipped. I don't know. We'll Z. Okay, so then GT. So this is LT. Okay. And this is phase 0. Oh. And do I have any others? Uh-oh. F. I guess you're right. What? Do I need more denominator over here? I thought it worked with any. It cross multiplies the denominators. No, yeah, it doesn't work with any. So the sum, the cross multiplication has to have the same bit width. So what is this? This is 5 3. So I move the 3 over there. So it's 6 equals 3 plus something. What am I doing? Num 1, num 1. What? Negative? What? Ouch. So what? Do I have to go like fix 3? Or is that one like this? I'm confused. It's not always nice. Oops. I gotta keep the thing together. Gosh, golly gosh. I cannot see this right now. 3 over 3, right? So now it's a 4 over 3. Okay, so what? This has to be 2 then. I don't know why I knew that. Okay, the whole thing is silly. Wait, can I do a 0? Wait a second. That is interesting. 0. As long as Binum goes to 0, that would actually be nice to have. So is 0 width number? It's like a number that isn't there. That would be great. Anyways, maybe this fixes the problem. We need to keep the ratio together and just compare it to another ratio because it takes into account the sign of the denominator when it does the thing. All right, we got more infinity loops. Yeah. It could still be backwards. So let's see. Don't split ratio. So this says less than, I say less than. Greater than, I say greater than. All right, so, oh, I put that on the wrong scoob. Okay, so now what if I swap it? Bop it. So that's like that. Nice. And then GT. And then those are the only other two. LT. What if it's like that and it was wrong? For some reason, I like just testing it instead of thinking about it. Still got an infinite loop. Dang it. Dang it. It's close-ish. I kind of want to explore what happens when you have a zero width number. Because it would have to have special empty impulse for like multiplying. So multiplying by it, you would need to just give the other number. I'm curious if the algorithms would just like reduce to that. I guess it'd be better to specialize. It acts like 1 when you multiply. It acts like 0 when you add. Well, no, you can't add. That's true. You actually can't add. You can only multiply by that. That's cool. Well, you can add 2 together. So you can add 2 zero width numbers together. And what do you get? You get the same thing, the same zero width number that with 0 bits, 0 size. Wow. 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 Okay, what if I do that? Does it kill me? Yes, it would. But can would it work with the macros? Cuz like I could add another column to the holy triangles with like zeros in it potentially. I am curious. That's so interesting. It doesn't have to add. That's so interesting. I think it's baking time. It's snowing. It's cold, man. Hello. I wrote a big algorithm and I'm sort of debugging it right now. Hmm. Probably unit tests, huh? So, like, it should probably work on a cube before anything else. Buh. Ugh. Buh. I think I'm gonna go cooking. Pull requests. Did they merge them? Did they do it? They merged one of them. Gut hub. Nope. Wait. Oh. Yes. Let's go. All right. Did we get a comment? Sheesh. Let's go. Nine, 10, 11. Gaming. No way. No way. V nice. I need to make like dinner, dinner. Ugh. Noise. What could be wrong? What could go wrong? Why don't I write a unit test and then I'll go and make dinner. All right. Unit test. Test it. Test. Well, it doesn't need to be at the bottom. It can just be right here. Planes to faces. Wow. So we can just go like test. It works. Planes to faces. So we go like, let my man. How do you make a hash set? Can you make a compile time hash set? Can you make a static hash set? I feel like you can't. Hash set. Oh, whoa, 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 whoa. Whoa, 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 whoa. What is that? Oh. It's a function? Mod. Oh, it's the module. Okay. Oh. Oh, well, that's cool. Difference. I did not know you could do that. Lazy iterator producing elements in the difference of the hash sets. Wow. Wow. That's useful. I did not know about that. Okay, so we do like this. Let faces equals to, it's a one of these. We go equals to face. Yeah, literally, I could just use these, like. Uh, as it so happens, cubes are really easy to make. X, Y, Z, and then, guess what? Negative X, Y, Z. And then that's it. So this iter collect. Into iter, I guess. Please. Please, sir. Missing generic argument. It's a something, okay? Cool. Okay. Monkey gon' chop banana. I have music. Does the iter work as well? It's a reference. Oh, okay. Okay, and then we call planes to faces. Oh, actually, we don't need to specify, do we? We just collect it and then pass it in and then do it. Unwrap. And that's the test. Wow. 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 So we can do something somehow, somewhere. Lib? Where am I? BSP loader? Cargo test. And it'll probably die forever. As we've seen. Death. What? Did that just work? Huh? So let's go do no capture. How do you spell? Huh? Huh? Isn't it supposed to... Oh, did I... Oh. Okay. Can I debug it? Debug. The bug did it. Do it. Do it. Does that... Okay. Sure thing, bud. Okay. Okay, so this is actually wrong. Oh, no, it's not. Okay. Okay, so what the hell going on? So we got 1, 2, 3. Huh? Why am I missing it? Did I do it wrong? So the algorithm just worked there. So or it did something. That's very interesting that it did something. How many are there here? So, okay. Earth. 1, 2, 3, 4, Okay, so there's 6 triangles making up this cube. Doesn't quite sound right. So that would be this sort of business right here. So I assumed that I had previously pushed when we find face 1. Because we already did the intersection with face 1 and face 2. So if we find a new face and compute the intersection, then that's great. But oh. I see. So it's still new information, but we can still like make yabba do about it. It's fine. So the deal is I need to write down my reasoning here. So the next face we see, next face to replace face 2 is the face is face 1. This is the last vertex. All right, let's see if that fixes it. 1, 2, 3, 4. Well, yeah, okay. So, okay, what's the 0, 1, 1, 1, 1, 1, 1, 0, 1, 0, 0, 1. I can't do that in my head. I don't know. So one of them should stay solid. So maybe it's the last one. Solid, 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 solid. Okay, this one should toggle. We should have 2 of each. Okay. Okay. So Z is -1. So I mean that looks right? So we have 0, 1, 1, 1, 1, 0, 0, 0. Yeah, no, that's all 4 corners. It worked. I just forgot to push the last face, but we still have an infinite loop for some reason. Like it's not working in other cases. And it's like degenerate mesh stuff. I could hash by normal and then just like get rid of the degenerate faces. Yeah, I'm gonna go cook and decide what to do. Guess what? I am making white chicken and carbonara sauce fettuccine. Mamma mia. Why is that in there? Oh, it's cold, man. It's cold. You know what? I've got some stuff for that. Oh, yes. I never wear hoodies. Oh, yes. I got the programming socks and the booties. I have never worn this hoodie before, ever. I have worn the boots before, though, and the socks. All right. Ugh. Okay. Time to put this stupid food package thing together. It like looks like a big thing, but it makes like a tiny little bit of food. So I bought 2 of them. And it is gonna last 2 days, but I'm gonna cook it once and then cook it again. Nice lunch. It's literally just this and this. Like, it comes like you're supposed to microwave it, but really microwave it. All right. Hopefully, I don't spill too much sauce. Hopefully, I don't spill any sauce. Okay. Alright, so we're going to start with some sauce. Oh, it smells like carbonara. Shocking. Uh-oh. I need to open it more. Wow, it smells like carbonara. Okay, so that is standing up by itself. I'm going to not want this on my hands. I will get my hands messy again. Okay. Noodle 1, and then noodle 2. Don't knock that over. What? It like ripped a little bit and then didn't keep going. Open! Bruh. Fine. These scissors don't work very well. You have to use them very carefully. What is that? Sure. I can just put it on one side. Got it? And then the other one. Whoa. 4090. Who has a 4090? Okay. So I want to fill this up with sauce now. Notably, I want to cover it so I don't have like toasted noodles. Fortunately, I have another sauce packet. Ugh! That's on my pants now. Looks delectable. I've had it before. It is quite good. What's even more astonishing is that there's one that tastes even better. That is sometimes available at Costco. This one I got from Save-On, and it's not at Costco. And this is the second best one. And there's other ones you can get at Costco. I know all about the pasta, the pre-packaged pasta that you could buy. What is that? This is white chicken carbonara fettuccine. It's like, it sounds as good as it tastes. It's uncooked. It says raw egg in it. Oh, it kind of tastes like it too. Okay, that is, oh, I just marked my face with sauce. Alright, let's see if I can do sauce packet number 2. Right. Did you order each part separately? Does it look like I ordered each part separately? You can go to the YouTube stream and seek back a little bit to see me bring it over. Handy YouTube seek history. I actually used that on stream today because like I almost deleted some code. I wanted to see what I deleted, but I didn't actually delete anything. And I knew because, oh my. Oh. Oh my God. So we go like this. Oh, my fingers are wet now. It's not quite the sauce coverage I wanted there. It's good enough. What do you suppose is wrong with the algorithm? Why would it be doing like that? All right. There's a bunch of chicken. There's a bunch of noodles. There's a bunch of carbonara. It's ready to go in the oven. Here we go. we'll cook that for 35 minutes. On. Stupid slow phone. Data usage. Why would there be data? Oh, why did that happen? Why am I not connected to Wi-Fi? Connecting. What? It's literally right there. Bruh. Bruh. Alright, all the waste. Throw it away. Alright, so the Cubus works. Cubus. Okay. I did not expect this. I didn't. Oh, you can't see what I'm doing. I'm like cold. If you couldn't tell. So I didn't expect that it would like exit before the last vertex. I thought it would. That's why I put it at the top here. I guess I could actually. Put it at the bottom then. So I could go like this and then put the break right here. Oh, yeah. No. No, I still need that. What the hell am I doing? I want to rotate the algorithm a bit so that it puts the right amount of vertices. So I guess that would be like this. So check at the top of the loop. So if face 1 is equal to face 2, I think that would work. Let's see. Test it. 1, 2, 3, 4. Yay! So now there's no special case. It's rotated around the loop body in the right amount so that it does the exact right amount of work. It stops at the right place. We push the vertex we already had. Wait, what is up with this? What in the tarnation? That looks suspicious. I think I found a problem with the algorithm. Thank you, Rest. Okay, so what's going on here? We have a new point. If the face we're replacing occludes the new point. Yeah, so that was wrong. GG. Okay, that's probably why it didn't work. This probably will still work because like it's a really simple case. I may have just fixed the algorithm because like it seems like the setup was bad. Let's see. Do it. All it takes is a little break doing some cooking, and I guess I don't know yet. I don't know if it's working yet. Does it show physics only? I probably want that, don't I? Wait, did I just push printing? Oh, debug faces. I see. Shut up. Okay, it's not crazy. What? Oh. Okay, so I want to take this, rebase, and bop. True. So do we just need this? Do it. And not this. Okay, so now it'll show the physics and we'll be able to see the physics and maybe it'll look great. It could just work. It could. Is that a loop? Looks kind of loopy. Okay, 964 negative. So it's looping to there. So this is face 1. 709. Which one is the closest to 709? None of the above. Oh, this one. No. This one. Okay, so it's still not rejecting the degenerate faces. So I think the algorithm was wrong, but it may not be able to handle the degenerate faces. I'm thinking about the carbonara. Double check I have a timer in there for 10 hours. What am I doing? It's already been 10 minutes. Okay, so I'm thinking I can like do like a weird iterator. Well, no, I can't use the pointers then. Ah. I don't want to allocate twice just to deduplicate. Why are there degenerate faces? Bruh. Oh my god, bruh. Well, the cube works. So, in simple cases, the algorithm is gaming. So, could it still be the setup is wrong? That was definitely wrong before. I wonder if I don't need this. Let's see. I wonder if it'll infinite loop. Oh. Test. Does it infinite loop in the test? Nope. It would be faster if I don't need it. I wonder if it's wrong as well. Cause like, can you, if you like find a better face and then you go back as well? Interesting. So it seems like it was just wrong. I don't need the remaining face hash set. I can just loop over all faces. Potentially. I just had the intersection test wrong. Seems right. I love continue. I love continue. New face. Okay. Face 1, 268. New face. None of these are close. So new face is -1. So what is -43? So it says, oh, face one is 1Y. We have that. None of the new faces are even close to that. If this isn't degenerate. Huh? What does that mean? So we got we got face 0, we got face 1, we got face 2, and then we kept going around face 3, face 4, but it's going in a loop that doesn't include face 1. So it's just going around in a circle. We found some kind of face 1 that's not actually a face 1. Shouldn't that be rejected right here? Like this, that should be this case. This is it's degenerate case. But that's face 0. But like if face 2 was degenerate, it would be replaced right here. Equals new face. It would find the face that occludes face 2 and replace it. Oh, good God. Face 2. No, yeah, that's right. So apparently we don't need the Dubert. Oh God. Okay, actually I can do it like this. Oh, I can do better. Merp, 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 merp. What did I just press? W. What? 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 Okay. What was that? Okay, so this is remaining faces not needed. It was just wrong. Last comment. Prev. Oh my God. So then I can go like this, rebase, and bop. And we're back. Okay. All right, I want to pop this. Wait, I thought I made this capital G. What happened? Oh well. Oh, that should be on that, shouldn't it? And then these are just prints. Oh my God, that's why. Okay. Bop, 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 bop. Okay. All right, let's run the same code again and see if it does something different. Nope. It always goes to a different one though. So none of these are 64, and none of them have the same normal. Like that's okay. One is the same normal. Okay, so that is this case is degenerate. It does have the same normal. Right. Collinear. I would very much like the algorithm to sort of reject the degenerate faces rather than having to like detect collinearity, because like that's whack. You know? Whack. You know what I'm saying? Okay, so what if there is a degenerate face in the test? What happens? So I go down here, and I go like, ooh, there's a degenerate face in the test. Ooh, it's a degenerate face. Ooh, what happens? That'll just hash out, actually. Well, yeah, it's because it's a hash set, so that'll hash out. But if we have anything, like epsilon is weird, but I'll just do it like that. It's a different number. Oh. What do you mean, okay? Oh, I don't have any prints. I'm like waiting for it to print. Oh my god, bro. Okay. Give me that one. Bop. Come on, dude. Why? Your local changes? I don't care about what... Like, that. I'm adding them together. Oh my god, bro. Okay, 1, 2, 3, 4. So does it? Okay, so there's the epsilon, but then the other side is fine. So that's what it does. We shouldn't see any -1. That's confusing. This number means -1. This number means -1/2 to the power 32. It's a very small number because it's a fixed point. So we shouldn't see any, we shouldn't see this here in the Z component. And so far so good. Uh-oh. Okay, so it appears to have not rejected a degenerate face. What a nice unit test. Okay, so 1, 2, 3, 4, 5, 6. So we have 6 faces. But it failed to reject the degenerate face on one of them? This face is completely wrong. I'm going to have to think about that. Boy. How are we doing for time? Please. 10 more minutes. I could take it out right now. I'm going to go check. Oh, no. No. Don't take it out yet. Ooh, I think I could, though. I like cooked. Mmm. Carbonara. Mmm. It's like eggy, bacony. Oof. Why is this number? Why? Why would you do this? So, if we go over here, if we go to the place where it's supposed to reject it, so that's face 0. So it should be like exactly this case. Okay, so if we have some sort of new face that is not face 0, not face 1, not face 2, and the point on new face, face 1, face 2, is this backwards? Does it need to be GT? If the point is in front of the face, so this number is bigger than this number. New intersection dot face 0 is larger than dot product true abort reject face. That looks correct to me. Oh, less, that's this number less than that number. So the face's dot product is less than the point. That looks correct. Bah. Well, that looks like the problem. That looks like the problem right there. My cube with a degenerate face is not having the degenerate face rejected by the algorithm right here. On all the other cases where it was not picking the degenerate face as face 0, it was doing it. So here, I think it's the loop of it's the loop where face 0 is the degenerate face. And so it's like picking its stuff nicely, pick. And then it shuffles the other faces and good, very good. And then we get to the part where it's supposed to check if face 0 is a degenerate face. And it just doesn't. It doesn't. Why? It could be that the check is backwards. What if I do that? What happened? It failed. Empty faces. Okay, so it rejected all faces. Makes sense. Oh, I smell it. Oh, back crack. I do not do that. Why? Oh. Um. Sure, whatever. Sure, whatever. Okay. I want to go to Master Branch and explore zero size fixed point numbers. That sounds cool as heck. So if we go to the holy tables, the holy number tables, and copy this column. And change all the ones to zeros. It likes it. Oops. It just takes it. Okay. We've expanded the holy triangles. What the hell is going on right here? Did I just add that one on because I needed it? I think I did. Zero. God damn, how does that work? I don't understand. Ugh, okay. So what happens when you fix? Yeah. Okay, so we got comma 1 here, comma 0. And then this. Uh-oh. Okay, so wait. Oh. Why does it start at 2? It's food time. All right. You have got to see this. Here it comes. Oh. Sizzle, sizzle. This requires a kingly portion of milk. So I had an idea. I don't know how to fix the algorithm, but I do know I can detect an infinite loop and get the hell out of there. I want to see a bunch of cubes in the map. I want to see it. I want to see that. So I'm going to eat a little bit of carbonara. And then I'm going to do that. It smells a bit odd. It does not taste odd. This sweater is really helping. Looks like it stopped snowing. NVIDIA moving towards Rust. Is that on Phoronix? Are you talking about like the Nova driver? It's on Phoronix. We're rewriting all our drivers in Rust. We think it'll be better. Wait, is this transposed? What the hell? What the hell going on? The second, wait, what? The second number. Why is this like this? Variable refresh rate? I thought you said it worked. I got the new driver. It's working for me right now. The new driver. Oh, I don't think they would release it unless it was feature parity. The alleged Rust ones. I was making stuff up. I have no idea. Fine. I'll give in. Bisect. NVIDIA engineer. Red Hat likes announcing things. What are you talking about? We're gonna move to Rust. Rustifying the Linux kernel scheduler. This isn't moving to Rust. This is a kernel scheduler, which we've seen one in Rust before as well. This one. Extensible scheduler opportunities. Oh my goodness, it's a song. All right, distraction over. Why is this table transposed compared to the other ones? Procy. Phoronix Comments is a special niche place on the internet. Why is this number not the same as... Okay, so it's going like this. Okay. Okay. I'm so confusion. RHS, LT, LHS. So the right hand side is less than the left hand side. The right hand side is less than the left hand side. Two. Huh? So this was a copy of that. 2, 3. But that's not the same. 2, 3. So it's supposed to go like this. And then that. Now we have an exact duplicate like this. 2, 1, 0. So that doesn't make sense. That does not make sense. That doesn't make sense. RHS, LT, LHS. So what is this? 3, 4, 5, 4, 5, 6. I think that's it. I don't think it makes sense to do anything else. That is annoying that table is transposed. Trigger brushes identified by texture name. Who is saying that? What would that mean? Texture name. Okay, continue with macro expansion. Okay. Did I do it? Okay. LHS, LT, RHS. I think I got it. All right, and then this one, I can say 0, 0. LHS equals to CBA. Okay. Not congeneric. What is that? Can I go like 0, 0? What is this? Square root. Can I do that? Or would it kill me? You can take the square root of a 0 size number. I feel like you don't want to do that. Paid actors. Unfortunately, it's preaching to the choir. They don't pay me because they don't need to. Oh, that's what I want you to think. Okay, is that all the stupid macros? Definitely not. I gotta go find all the stupid macros everywhere. Frickin' macros. Tests. Yeah, so let's do test wide mul 0 size. Fixed 0 0. Oh, really? Really? Oh, really? Are you good? Okay. So when you multiply it by 2, so when you multiply nothing by 2, it's not 0, it's actually just a 0 size type. Nothing. So this is the only type that can do this. Yeah, I know that. God damn. Alright, so everything here should be equal to 0. Ah, ah, ah. Let's see. Bint 0. Okay, so the library I'm using doesn't do it. That's fair. It's kind of a hack anyways. It's basically just a fit into the ratio thing. Yeah. All right. Well, that just straight up means it doesn't work, I think. Interesting. It said it's a typo, but with a capital I, it's like, I've seen that before. That's interesting. All right, that's cool. All right, we're going back to the old testy tests. So why is it not rejecting the face? I reject your face. Oh yeah. Have you played with Unreal or Unity? Barely. I touched Unreal briefly, and like implemented bhop. It's just a giant pile of sludge. It's a giant kludge. I'm writing my own game engine, and like it's lean, it's clean, it's mean. It does exactly what I need, nothing more, nothing less. And that's exactly what I want. I'm not a game engine kind of guy. I kind of resonate with the feeling that like Unreal Engine is ruining games, where like the performance is so bad and it's so unoptimized that if you don't have the exact PC that the developer made the game on, you're out of luck and you can't play the game. Threat Interactive. That guy's funny, serious. He's very serious. He's not funny at all. I think it's funny how serious he is. It makes sense to be serious when it's your business. That was good. That was good. I'm gonna clean my dishes. I'll be back. Fix fell. If you're still here, I'll show you the game. Oh, I guess I gotta use a branch that works. All right, we'll go here. Build it. Oh, it is. This is my game. So it's just B-Hop. If you know B-Hop. So I wrote the graphics. I wrote the physics. I wrote everything. So it's literally calling the GPU. It's being like, draw this polygon. Now draw this polygon. Now draw this polygon. And then the physics is like, does this part intersect with that part? Does this thing intersect with that? It's very complicated. But I've gotten it working this much, at the very least. Oops. Bah. It's not perfect. In fact, it's pretty buggy. And there's some issues with the physics doing too much work, which causes some lag spikes, but I think I can figure it out. So what's my point? Surfing still isn't possible. The release I did, if you saw that, has a hotfix for it that kind of dodges the issue without actually fixing it. Would you believe me if I said people actually come into the stream and say, wow, the graphics look good? That just, like, what? What do you mean the graphics look good? It's literally flat rendering. There's no lighting whatsoever. It's just take the texture color, draw it to the screen, and that is the rendering. There's a like reflection shader, but like that's drawing the sky color. What? A portion of people think this is good graphics. Some people like basic stuff. I like being able to see. So some of the Roblox B-Hop maps have beautiful reflections. Some of the Roblox B-Hop maps have like really dark sections that you can't see, and that does not happen when the lighting looks like this. The lighting. So what? So I think I want to have a simple graphics mode in the final game that is like, probably it would look better than this, but probably I wouldn't even add like ambient occlusion or anything. I would just, it would just be like Fulbright, source engine terminology. It's just like you can see everything and it runs extremely fast. And it would just be like the most optimized graphics mode. But then I want to have like fast but nice graphics where like the target frame rate would be like 240 frames per second or something. And that would, yes, right. And that would be a reasonable graphics mode to play on if you like good graphics. It would have, I don't know, like, I would want to make it look like Doom Eternal. Copy some stuff from that game. That would be super cool. That would take me a long time to do, but I got time. I'll do it. I'll learn about graphics. And then I also want like a toy rendering mode that I can implement ray tracing, and I can like just like target is 1 FPS. And like you would use that for like cinematic renders of your replays. That's my my vision, my dream graphics scenario, dream graphics setup. I think that'd be super cool to have those options. So cool. Oh my god, it is so fast. Oh, I don't make that. Do you have UV map? So you can't really do textures on meshes without that. So yes, it uses, and you can see it here as well. I have meshes that have textures. I guess this stage, this section of the map doesn't really showcase textures very well. Like it could very well just be some kind of like simple shader that is like generating the look of the platforms, but no, it's textures. Oops. Ah. Dot product diffuse lighting. No, it's literally just reflect the incident direction, sample the sky texture, blend, done. That's it. It just blends according to the dot product and samples the sky texture. It's like a one-liner. I have not worked very hard on it. I've mostly been like working on the technical aspect of like the game engine and the gameplay mostly. I did a lot of engine work at the beginning to like make there be a game engine, but like it's not really a game engine. It's more like the bhop engine. Like the game is the engine. It would be difficult to mod into like a shooter game. You would have to make the entire animation system, the entire gun system, the entire bullets, the entire like enemies, the entire everything. Like it's not a game engine. I've never really liked that though, using someone else's library. I would be making all that stuff myself anyways. My friend has a first person shooter game, and I really want him to like pick up Rust and like write his own engine, because he's the kind of person who would write some insane stuff, just like me. But that's Trey. He said he was like interested in porting the game to like my engine, but that would be an insane amount of work for everyone involved. Oops, his stuff is like, the way he did his physics is like just so like my game state is tiny, like it's a kilobyte for everything. But in his game, the weapon animations and like all of the bullets in the air and all the stuff going on, the game state is huge. So you can't like just shuffle it around like nothing. So there's different considerations and design decisions that you would make to optimize for that. Whereas with my game, you can just kind of chuck around an entire game state. I don't actually do that. Like I only have one game state, but you could, well, I don't know actually. Like if you're sending, I mean, that would be what? 1,000 times 1 kilobyte every second. That's like 1 megabyte per second. If you're sending, that's like kind of viable with modern internet. You could send every physics state, every, like just period, every single physics state, just send it. Like it's way better to send the instructions, but Wow, you beat the map. All right. So now I can go to the replay. Oh. Why did that take so long? Did I not press the right button? I swear I pressed B. Was it like thinking about it? There's no way. I never did that before. I guess I just missed the key. I guess I didn't press it. Well, I'm so glad that I got the algorithm written. There's no way I could have written this yesterday. It was just, I had already done a bunch of work, and like this took 7 hours to write the algorithm. It's not working completely yet, but I do have, it does work for a cube, so that's good. I need to figure out why. I'm gonna write this down. I need to figure out why do it be doing like that? Why does cube test not reject degenerate face? Okay. Oh. Okay, yeah, there's like stuff on the table. I'm gonna wipe down my desk. Oh, right back. No sticky. You could be sure of. Oh. 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 Right. I had that idea. Right. I'm saving this bot. That didn't work. There it is. It's so fast. Did it do it? Oh. Did I? What? Huh? Why did that happen? Writing bot file. Finish writing bot file. Nice. Herman Miller? That's new, yes. It is magical. People say it's not magical, but for me, it's magical. It fixed my back. My back was like achy all the time. And when I got this chair, my back started like cracking constantly. It was like, I think that it was literally changing the shape of my back. Garbage concoction. I thought you wrote garbage collection. I'm like, what? Garbage collection? Okay. Test degenerate face. Oh, no. We can go here. Okay, so if I go like, what up? I'm going to actually fix this to be a separate test. Okay, I'm going to put the test at the bottom. All right, I'm going to do it like this. Mod test. Oh, it's like this. Oops. CFG test. Shush. Ah, jeez. Friggity frick. You super. Shut up. All right. Test planes to test the cube. And then why is it like this? Test cube with degenerate face. Your face is degenerate. So then that has none. Yay. Okay, great. Cool. Okay, so move the tests to the bottom. Move tests. Actually, I can just say this is the same, but completely different. So it's an additional test that tests the degenerate face, but like, whatever. Okay. Ooh. Chairs that reach up behind your bed aren't your head aren't as good for your back. Yeah, this came with a headrest. Or, well, after it was assembled, you can attach the headrest. And I did attach the headrest, and I used it like that for a while. And it's like, I usually don't like headrests, but it was like, okay headrest. Still the best headrest I ever used. But I took it off, and it was better. Like, it would, like, sit in the nape of your neck instead of, like, pressing against the top of your head. It would, like, sit here. But, like, I think I would still, like, move forward because it would touch the back of my head, my head, and I just, like, would instinctively not want that there. And so I would, like, sit with bad posture, and it would, like, it made the top of my back curl while the headrest was there. And after I took it off, the top of my back started cracking, crack, 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 crack for some days. And now my back feels great. My back doesn't hurt. It doesn't hurt. Herman Miller. It is magic, but holy hell, is it expensive. Boy. Okay, so we got the test. Very good, the test. Ugh. I was going to do the thing. I was going to go like, what if we do not care? Okay, so the BSP. Okay, so, right. Okay, we do not care. So it goes to do the algorithm, and then there's an infinity de loopus. De loop! All right, so let's do detect loop. Let detect loop. Surely there's not 100 faces. Let's go with 200 because we did actually see 171 faces on that one thing. I had an idea. Oh God, it doesn't matter. Is this a Boolean option? Oh. Bah. Okay, whatever. It's not as skookum as I thought it was. Le pou. Le pou. Le pou. Okay, so now we're just going to detect an infinite loop. And once we find an infinite loop, we just give up. Okay. So, can we load a map? If we detect infinite loop and do the things that work, create objects that make any sense? Or do we still have lots of nonsense? I appear to be standing on something. Well, oh, there's a wall there. 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 It seems like it's not very related to the map. Okay, let's use the physics render. We can go like this. Show physics only, rebase, Yahoo. And bop this. And then let's see what it looks like. Turn the debug viewer on. It's doing a different infinite loop. It didn't do that before. Why is it like non-deterministic? Oh, oh. I think I know the problem. Do you know the problem? Look at that. So we're going straight down. Yeah. Okay. Let's go here. And we'll do... we can call this transform position. So, yeah. Well. Congrats. Oh, you're right. Yeah, that's pretty conclusive evidence that your your interpretation of the information has meaning. Okay, so where did I copy that stupid code to? Right there. There it is. All right. Val transform that normal. Do it. Don't need that. Hold up. What if I take the and do the All right. All right, let's run it. Run the track. Interesting that it's there from both sides. Shadows. No. No. This is various convex solids. Jumping on shadows. So let's render both. All right. Detect the loop, the loop. Okay, and then we'll put this on the Uber branch. Yeah. Bevel issue. Are you near an airport? I live next to the SkyTrain. So it's a train going by. Brush sides with bevel does not equal 0 cause problems. Yeah. All right. So, it very much looks like the physics are not aligned. But let me grab this. And we'll show both at the same time and see what it looks like. I don't think they're going to be aligned, but that's okay. We can see what's up. Oh, I'm a stupid. Okay. This was supposed to go in here. I just didn't remember to do it. Cool. Okay. The shadow jumper. It's not working, I think. It is working very, very, very well. We had nothing for the past long time. Long time. Okay, where is... Where's the graphics? What? Am I on the wrong branch? What's up with this? Oh, it's trolling me. Okay. What? Where's the graphics? Huh? Texture references. couldn't be working, could it? There's no way. What if we put this off? No way. No way. You're from Canada? Yes, the Sky Train. Give me away. Yeah. Oh. Let me through. Huh. No way. What? It's correct? What? Wow. What? No way. That's a trigger? That's a trigger. So all I need to do now is like stop doing physics for brushes that don't matter. So there's like player clip, but then there's like other types of brushes. The tumor brushes, not the tumor. So that's why it looked, that's why you couldn't see any graphics, because it's in the same place as the shadows, the physics. Wow. We got physics. Wow. Check for names. Yeah, I feel like there's... Okay, I have a better plan. Here we go. I know what to do. Where's the old... This guy. Give me that. Do it. All right, brush to mesh. I feel like it should be... Well... So if it's not a player clip, don't do it. Don't do it. Wow. This has been one of the development sessions of all time. Uh-oh. Where? What? What? Huh? Oh. Is not everything tagged with player clip? You may be standing on a trigger. Why? What? Solid. Okay. That's helpful. Oops. Let me in. Let me in. That also includes triggers. That's how my triggers work as well, so. Let me in. Let me in. Let me in. Where are the physics bugs when you need them? Yeah. Let me in. Let me in. Come on, physics bugs. Come on. Bug. Oh! All right. All right. Ooh. Okay, there looks like there's a surface right there. Can I just jump on nothing? Ooh, okay. So, God, this is so amazing. It just feels like I'm playing Roblox Arcane. Wow. This is loaded from the other map. Try a surf map. It's not gonna work. Well, surfing is not gonna work, but the collisions would probably work. Collisions everywhere. So, oh, no. Are those even surfs? Oh. Let me in! Let me in! I don't have no clip. You literally can't no clip in my my thing. Oh, I'm in. I bet you can touch this though. Oh. Strange. I don't know. Let's look at Omnific. That one's complicated. That would have lots of stuffs. Yeah, this one was the big lag last time I It's just platforms everywhere. Oh my god, bro. It's got to be the ones that didn't work correctly. I'm thinking when the algorithm fails, but it doesn't detect an infinite loop. So it actually exits. Those are the ones that are wrong. Ooh. All right, touch? No. Oh, are those props? I think they're props. What is? Oh, I can touch it. Let's go. Oh, cool. Let's go. Does it continue with messed up geometry if a single side fails? It depends on if it enters an infinite loop. If I don't know. I don't really know, to be honest. It will generate no mesh if there's an infinite loop, but if the algorithm is wrong, then it'll generate whatever it generates. It's sort of UB. Why does it not work for the It doesn't seem to work for slanted faces. This is definitely a breakthrough. I want to go back to Arcane. We can go to Area Portal. Load this cool map. Look at that cool map. Where's the freaking start zone? I don't know. Oh, got him. I'm jumping. I'm in the game. Oh, I'm so good at B-hop. Oh, but those ones don't quite work. That's one way to do a portal. Damn, it's like pretty good. Oh, there's just a plane in the middle of the arena. Man, the textures, I think something is wrong with the textures. A tumor. I got this feeling that the textures didn't decode properly, but they did it in a really cool way that's very interesting looking. I'll have to come back to that. Interestingly, they seem to have worked fine on Arcane. Hey, do you know where where the spawn is? How do you know where to spawn? How do you know where to start? Entities. Yes. Print out dot entities. Let me in. Let me in. Let me in. Oh, I'm in. No. No. Let me in. Okay. Start zone. God, it feels nice to play. No! Let me in. The tumors. I can't get up. There it is. Man, can you imagine? Oh, no! Let me in! When are the physics bugs when you need them? There it is. Ah, I'm stuck underneath. Oh my god, bro. Oh, let me up. Oh. Oh no. No. There's another one there. Okay. Oof. Jumping. I can just jump here, no problem. Just making sure I'm not on some kind of plane. Damn. It's so close. This is awesome. Oh, this is gonna screw up. Oh, what? What just happened? Ah! I wonder what that is. Okay, it's gotta be the algorithm failing, right? Displacements are used. What? Why does this one not work? That works. Damn, it feels good to be a gangster. That doesn't work. Oh. Ooh. Is this B-Hop on the new engine? Yes. This is a source engine map, and I am decoding the physics for the first time. And sometimes it works, sometimes it doesn't work. There's supposed to be invisible walls here. I don't know why those aren't working. Why are the physics done differently for like the spawns versus the platforms? Ugh. I wonder if sewer stage is gonna work. Welcome to the sewers. Oh, it does work. But we got some kind of roof here. Bevel does not equal 0. God damn. Interestingly, it feels like I'm gaining super hard, which is like how Roblox is supposed to feel, but like it's off for some reason. Nope, missed that. Yeah. Man, it's there's so much that's like correct. Can I go into the cubby hole? I must know. Nope. Ish. I do hit the roof there. I do hit the back wall, but I don't hit the side walls. Bah. What is the Squidward picture? That's a great question. How did Squidward get in the game? Just kidding. It's the default texture. So if it doesn't load a texture, it just puts Squidward there. It's my game engine. Let me in. I don't think the surfs work at all for some reason. Your texture didn't load. Oh, that's interesting. It's actually just a straight shot, huh? Let me in. Let me in. What do you have if a mesh doesn't load? Nothing. It just doesn't. There's just no geometry, right? Let me in. Let me in. Oh my god, I can't get down. I need no clip. There you go. All right, let me in. Let me in. Let me in. Yes, I'm in. What is this surface? Oof, okay. I want to go back to the start. Oh, there's just random walls everywhere. Bruh. Oh, it's like irritating. It's actually just irritating. It starts working and then suddenly it's irritating that it's not working perfectly. Instead of being like, woo, get rid of the triggers. So you're saying if it's not solid, continue. Or if it is trigger. What? Brush. A side with a texture starting with tools. A brush with a side with a texture. I guess I can just do this. I forgot. How do you do it? It's not side of texture info. So where is it? Texture info, texture info, texture, huh? Textures info, handle face. Wait, what? Okay, so it's not there. Okay. Textures info. Get side dot texture info as you size. Texture info dot god damn texture data index. Let's go. So I think I want to handle this. Give me that. Capitalize it all. I'm a lowercase man. But then you have to allocate. I don't want to allocate. BSP is evil. Valve. Alright, so now we can do is smaller matches. S. Tools. Oh. Yeah, no, that doesn't work. I mean, I could probably make a pattern, but meh. Okay. Okay. Stop with the stuff in the way. Okay. Okay. So, I want to spawn in the right spot. Let's just rush around more. All right. So if I go through the level, am I gonna? Okay, this is the wrong way, or this is the right way. I want to go the wrong way. I want to go to the start. So far, so good. So far, I'm not smacking into any of these invisible tumors. All right, here's the start. Let's go. So the question is, oh, that's not good. Let me in. Oh my God. So the question is, oh my God. Do I, what's the question? I actually don't know what the question is. Run into anything. That's right. Is it too small? Is it too small by like a %? I think that's what's going on. I feel like too fast. I think it's like 1/13 scale or something. And this is a 1/16 scale. Like 13.7 or something. 5-man. What graphics card do you have? And you plan on doing another PC build video? I am quite happy with my computer. I've had this computer for nearly, actually no, probably 4 years. And it's fast. I don't need anything new. Right now I have 2 GPUs in the computer. Oops. I have 3080 Ti and a 3060. The second one is for a virtual machine, but I found out I can use it for AI, which is cool. If I have both of them, whoa, that's weird. Oh. Ladders are weird. Oh. Consult the wiki. Oh, why does that have... That doesn't touch. Why is the... Why do those surfaces never work? Seems like the large surfaces often don't work. Wonder if that's a bug on my end. So the next thing to do is to get the valve, or not valve, but the like CSS settings for bHop to like activate based on which map you load. Just go through the wall. Like if you can't go around the wall, just go through it. It's so the answer is obvious. Oh my God, you cannot go through that. Just kidding. 3070, 7600X. Your CPU is better than mine. I got 5950X. Well, I guess I have better multi-core, but... Oh. Your CPU probably has better single core. Why does the booster not work? Oh my God, you can't even touch it. Check what's going on with those that you fall through. Do you fall through those as well? Because like if it's only on my game engine, it could just be that the physics is like busted as well, because the physics is busted. But I'm jumping on the squares in source, but it's not source. Squidward. Oh, miss. Just go through the wall. My CPU good enough for even a 5080. Yeah, the CPUs have gotten really good. The CPU, the competition in the CPU market really made an enormous difference. Oh yeah, you can't actually do that. What is that thing? What do you think that is? Special no jumpy thing? What's up with the collisions? I just got them working. Well, I wrote the code. There were no collisions this morning. None. Just absolutely none. And I wrote an algorithm to convert a convex solid into a mesh, and it's working to some extent. So now I'm playing around. So tomorrow we'll have to see more stuff with the algorithm. It never works. We can really get going on the Valve map stuff. Valve should hire you. Yeah, for working on their 20-year-old game engine files. It feels like it should work. Like it because some of it works. It's like, oh, if I touch this, it'll do this. Because like I know the map. Does this work? It does. Can I touch this wall? I can. Let me in. Let me in. Did that work for a second? No. I'm getting befuddled. Make Gmod 2. What? I pressed reset and the map is gone. Oops. What happens if you keep falling? Nothing. Check it out. The game crashes. That wasn't supposed to happen. Alright, if I go this way, I hit something. Just like random surfaces everywhere. Bye bye. Bye bye map. I can still see it if I look in the corner. I'm just still falling. Ugh. Bugs out when I don't skip on bevels. Pretty cool. Cha. So I have all the other stuff merged up. Triggers. I'm totally gonna have to. Probably there's another thing. Probably it's not checking the name. Please don't be checking the name. Ignoring sides with bevels seems to make it work. Studio crashed. What's Roblox Studio? Android Studio? Vinegar, I see. So what you're saying is I should filter map based on bevel non-zero? How do you import Roblox stuff to source? With great effort. Size. Yeah, well, there'll be a filter map here. My sides. So presumably we can just unwrap this, or I could do it properly. What? So you're saying the surf's not working? Let's go find a surf. Where's it? Okay, there's one in the drainage. You think this will start working here? Nope. There's one. Ooh! Nice. So if I move the mouse, I just fall through because like my physics is busted, but it works. Right. Oh my goodness, you just fall through the whole thing. Yeah, so I think you may have a case of correlation versus causation, where the like tumor textures correlate with the texture Bing Bong, as well as the bevel stuff. Hopefully there's a more surefire way to figure these things out. Oof. Jump, 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 jump. So if you put a jump that's 1 nanometer above, it'll jump like 1 billion times per second and lag the game. Oh my god, bro. Because it like precisely calculates every single jump. The 1 micron bunny hop crash. 1 micron, you might be able to handle that because that's like 1 million times per second. I guess I would need to do some optimization, you know, but it's doable. So the surf thing doesn't fix this, the bevels, but it does fix that other thing. But not that one. Is that a whole thing a mesh? No. It's just like something funny about that. You just have a copy of Arcane yourself. Oh, that was kind of gaming. I have never hit the route that way before. Oh, was that a trigger? No. Trigger. So, some of the things are triggers. These ones. So does it like, no, you can stand on that. But you can't touch that. Oh. This is awesome. Thanks so much for your help identifying how the hell the stuff works. It would have taken me a very long time because I'm not so good at like using other people's stuff. I'm in the ground. Very good at making my own stuff. I don't know why I went for that. I was here, I get credit too. Do you know what this is? Wait. Oh, I can jump on this stuff now. Oh, hell yeah. Look at me go. So this thing had the same problem as the surf. Wee. Oh. Frost, do you know what's going on? How long have you been here? All right. Watch carefully. Run bhop arcane 2.bsp. We got physics on source maps. That's what's going on. It's a team effort. Ouch. Stand on the ground sector right before the spiral section. What is this? Spiral section. You talking about the spin here? This one? Oh, what? Wait a second. I stood here. Did I not just stand twice? The width of the brush. I was wondering that, but like we saw the huge ones that are in between the levels. I can just jump on those, right? Like there's one over here. You can just jump on this one, no problem. So the width I thought maybe was a problem at one point, but because of the wide numbers, it can never overflow. So, ooh, let's check it. Yeah. Oh, I want to do it now. Oh, I touched the roof. I just can't surf. All right, gotta aim properly. I missed. Oh, pfft, made it. Easy. Uh-oh. Ooh, barely. Oh, that thing works too. Oh, hell yeah. Nice. Do I hit the bottom side of it as well? No, that's correct. My physics are not supposed to do that. Damn. What? Huh? Is that a working cylinder? Oh my days. Is that a working cylinder? Ish. Ish. 192 sided brush. That's kind of crazy that it works ish. I could probably do a lot of debugging using that. Wow. Wow. I honestly did not expect this to work. I thought we were going to be stuck on it for a longer time. And we're not going to have stuff like this. We can't have nice things. Bevel. Surf. Document. Got an algorithm to go with it. Yep. Whoa. How long stream? 8-hour stream. Buh. If you have the BSP, I can take a look at it in Hammer. Yes, I have the BSP. You can actually get it right from Game Banana. You have Arcane. It's just that one. It's just this map. Oh. Wait, 41. Oh, it's a zip. I see. Very cool stuff. I never thought I would see the day. Wait, actually, with all the progress you've made, what happens on Omnific? Can we, like, fly through the skies? With all the stuff that's no longer... Alright, can we touch this? No. Can we touch this? No. We can touch this. No. Huh? No. 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 What happened? Alright. I have a feeling some of your filtering culling is correlation and not causation. Oh, I can touch that. Woo! Oh, can I touch the surf? No. I can surf for 1 millisecond. Oh, I got surfing! Okay. Tips be a little overzealous. Yeah, exactly. Oh, TIPS. Yeah. It's just crazy having the physics enabled on Omnific, and it doesn't lag bejesus. Because like before, when I did the like model as the physics, it was laggy. I think you were there. I think I did. You were there. Oh, okay. What about Enokia? Nope. Use an AI to figure out the correct quaternion rotations. I don't think you need AI to go through 256 permutations. We just need a transformation from valve rotation to not valve rotation. You know what I could do is take the transformed and untransformed rotation matrix and then turn it into a quaternion, or do the matrix inverse and turn it into a quaternion. That would probably work. Unless it's not a rotation matrix. Then it would not work. Like if the handedness is flipped. The chirality. Chai. Well, I'm very satisfied with the happenings today. All right, this one seems to work great. And then these help on Arcane, but unhelp on just little sussy tips. And then we'll put the BSP brush on this. Sure. Why did that happen? Might be redundant. Check if any brushes aren't solid. That is checking if it isn't solid. It's skipping it if it isn't solid. Oh. Great. So we're going to actually put those together. Oh my God, bro. Should be the same. Nice. Right. Infinite loop detect is like not really supposed to go on main. Oy, 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 oy. Damn. That was a good session. So, yes, why does the cube test not reject degenerate faces? That's probably the main concern for the algorithm. Oh my God, I can't believe the algorithm actually bore fruit. That's crazy. Buh. I don't know how big it is. Let's see. We can build the map tool. And convert the map. Oh my God. So we're going to go strafe, map. Oh, no, it's right here. Target, release, map. Help. Oh, I'm going to get all the VPKs. I don't want to do that. Never mind. I don't want to do that. I need to make it like Steam locate auto find them. So I don't have to do that. And I can just go like map tool Steam locate true. And then it just gets it. Steam locate true. God damn it. Okay. Well, I'm about done. And I definitely feel confident saying that. I feel like I'm allowed to say that after such a successful day, you know? Damn. We got some physics on the Valve maps. I think if I think the goal should be to like regenerate the baked model, like load the graphics from the brushes instead of from the baked model, because then I can like regionalize it and like it can go in the BSP or BVH is my technology of choice instead of the BSP. Like optimized is cool, but like culling 20% of the faces is not gonna make a huge difference. That was generation. Oh yeah. Buh. Well, that's it then. Friendship ended with world model. Do you still need the like models after number 0? Like model number 1, number 2? What the hell are those? I guess I could like actually do that right now. We can see what that looks like. All up. Watch this. The BSP. Skip 1. Uh-oh. Is that allowed? Oh, then I would have to do this. Yeah. Chain map. Yeah. So then it'd be like boom. Boom. Done. Gaming. Okay. Do trigger teleports and teleport multiples work? I just got the physics working. There was no point in like trying to figure out that stuff if there's no physics. So nothing works. Uh-oh. Oh, it's the infinite loop. God damn it. Okay. Handling entities. No, that's not what I wanted. Go away. Oh, this still has props. So I don't want props. I don't want no nothing. I want just the extra models. It's formatted like JSON. What? The entities? Good God. So these are the non-world models. Right. Interesting. Isn't there 4 portals? That's cool though. The side. My game doesn't look like that. This is the end zone. Weapons. Sunob. Bonus. What? Long map. What is that? What is that? I want to see it. Oh, it's the long jumps. So weird. So weird, man. What do you think these? I hope these are in the brushes. Like, screw the world models. Why? Oh my god. What is that? It looks like one of the surfs in the sewer stage. Yeah. Well, that's something. That's for sure. All right. I'm done. See y'all tomorrow. We'll, I feel accomplished. I might try to do some Roblox stuff. Definitely we can work on some of the game mechanics for the BSP maps. We can like look at like where do you spawn, where are the triggers, where are the stages, how do the triggers map to the stuff, and like try to get some of the game mechanics working. That would be pretty cool. See y'all later. Goodbye.